Hi everyone, welcome to the Strategic Design Workshop. I'm Helena, I'm going to be the moderator for this presentation. In a second we're going to start, but just a reminder that if you have any questions, please throw them in the chat and we're going to go through and do our best to answer those at the end. So with that, I think we'll get started.
Awesome. Excited to be giving this presentation. I'm Mike Corsetto. I'm the lead technical mentor for 1678. I'm also an engineering manager at a company making robots that clean solar panels. I'm actually I just finished my 17th, going into 18th season in FRC, and started working with 1678 in 2008. And I like to say that for this presentation, Austin and I have leaned heavily on a lot of very talented individuals and teams. Karthik, 254, among the teams that we've leaned on the most for this presentation. So a lot of the credit for the content in this goes to those groups.
Hi, I'm Austin Haddox. I am a strategy, scouting, and mechanical mentor for 1678. I work as a senior data analyst for North Bay School Insurance Authority. I'm going into my 8th year with FRC, and I started mentoring 1678 in 2019.
Awesome. So a couple things we're going to cover in today's presentation. We're going to talk for strategic design. Our focus is going to be about how to utilize the limited resources every team has to be as effective as possible in each of these areas that we're going to cover. So we're going to talk about the preseason and what you can do to leverage that time. We're going to talk about a little bit about drivetrain and mechanism design, electronics and pneumatics, what some keys are there to focus your resources appropriately, and then how to structure your build and competition season for competitive success.
So when it comes to design, it's really important that we don't overcomplicate things. So our golden rule on 1678 is keep it simple, silly. We need to define what our team can do, and we need to design something that's simple and won't break down. And if you ever look at 1678 robots, you'll definitely see a pattern of us focusing on design and functionality over powder coating and painting our robot and making sure it looks pretty.
That is 100% true. So let's talk a little bit about what you can do in the preseason to prepare your team. So for the preseason, one thing that we learned on 1678, and I think was a real turning point for our team, is that the time before kickoff in January isn't just a break to take off and not do anything. That used to be our team's mode of operating for many seasons. And then around the 2012, 2013 mark, right around there, we started operating more on a year-round basis. And a lot of those activities looked like preseason trainings, going to off-season competitions, but a lot of it was also experimentation and trying out new things, new designs. So a lot of the stuff we're going to talk about today might be new to your team, or maybe a couple of topics are new, like there's a new concept or a new mechanism design that you want to investigate. What we encourage teams to do is to try those designs out in the preseason, learn about them. If you have a little bit of padding in your budget, maybe buy a couple of parts and put them together and see if you can make a working mechanism for an off-season robot or just a special project. And a lot of that's going to rely on you learning from past FRC robots and past FRC games. What we find is there tends to be a lot of repetition. So that's a lot of what we're going to be doing in the preseason every year. Even for a team like ours that's been meeting year round for many years now, these concepts are still just as important in our 10th year of doing this as they were the first year we tried working year round.
Yeah, so with some off-season project ideas, try things that you've never tried before, a ball shooter, intakes, elevators, climbers. The kitbot is a really good thing to practice because it's really important that if you plan on using the kitbot, that your team is used to putting it together, since it's really more or less the same every single year. And so if you can get practice putting that together and getting it up and running in a couple days, you're ahead of 80% of teams out there already. And bumpers, of course, are a thing every year, and you don't ever want to wait to the last minute to put them together. So practicing getting everything ready is definitely helpful. For us, we never did a six-wheel drop center until we practiced it in the off season, and now it's definitely a staple point of our robots. We're currently practicing with swerve drive modules, and hopefully might eventually integrate those, but don't ever put something on your robot that you've never practiced or have any experience with during off season.
Yeah, and a lot of knowing what to practice is going to come from learning game history. So what we find is now that we're really like 30 years deep into FRC, but we're also like 15 years into VEX and 10 years into FTC. So there's a ton of cumulative years of competitive robotics to lean on as far as mechanism design goes. And even within FRC, we have games that repeat similar principles like climbing challenges from 5 of the last like 10, 11 years have had climbing challenges that look fairly similar. One of the more ironic ones was in 2007, 2011 with tubes, where you literally had similarly sized and shaped tubes that were scored on 3 different peg levels that were almost at the same height as between the 2 games. So there were a ton of lessons learned between those 2 years. I think one of the interesting ones more recently was the 2020 game used a foam ball that was from the same manufacturer as the foam ball we used in 2016. Granted, it was a slightly different skin material, but and a slightly different size, but the principles held true. So actually, when 1678 was prototyping early shooters for the 2020 season, we brought out our old 2016 robot and just adjusted some variables and started practicing shots with the 2016 robot, but with the 2020 balls. So there's a lot that you can learn from old games, and being familiar with the games is going to help you have good reference points when the new game comes out, if there's any similarities. But what we talked about just a second ago, you could go one step further and integrate some of the common mechanisms from past games into your preseason design training. So you could say, hey, there's a lot of the past year's games have used elevators. Let's practice designing and maybe even making an elevator, even if it's just going to be strapped to a test bench and go up and down. It at least gives us experience designing the mechanism and building it. So those are some of the values you get from knowing what past games were like.
Yeah, so we're on our golden rule number 2, where just like Mike was saying, look at past years and get those examples of what was successful, and then we can practice those during the off season. This brings us to golden rule number 2, which is steal from the best, invent the rest. We need to look up, what's the best robot from every year? What kind of designs work for shooting a foam ball? I'm not the best robot designer, neither is Mike. I think that we can both agree with that. And we're not going to reinvent the wheel when it comes to designing robots, because these teams have already done this for about 30 years or so. And there are some sneaky, smart strategies that these teams have come up with. So just look at the classic, competitive robots throughout the years. 2056, 973, 971. Actually, they're a little complicated, but 254, 330, rest in peace, 610. We want to look at these sneaky, simple designs that we can copy and make our own versions of. And, just like Robot in 3 days, we can take advantage of that and use that as our starting point for design.
All right, so I'm going to tackle Drivetrain just a little bit. If we go to the next slide, this is a couple of 254 robots, and I like to ask in our in-person presentations what people notice is similar between all the robots, and the answer is not that they're all blue. if you look closely, they're all utilizing a similar drive chassis structure of a West Coast drive. More on a higher level, they're using a tank style drive where they have a set of motors for their left wheels and a set of motors for their right wheels. And that feeds right into golden rule number 3, if you want to go to the next slide, which is use a proven drivetrain. And what this comes down to, I think Austin touched on it just a little while ago, but a key component of utilizing your design resources effectively is using a proven drivetrain that your team is familiar with. Now, for a majority of teams, this is going to be a tank style drivetrain. And actually, for a lot of teams, more than maybe teams want to think about, there's a lot of teams that should be using some form of the Kitbot drivetrain. And that is because if you use something like the Kitbot drivetrain, or just use the Kitbot that comes in your registration, you can have a drive base built in a day, and you can focus your design resources on the scoring elements that are going to be the things that actually get you points in the match. And I think a lot of teams can miss this because designing drivetrains can be kind of a it's an it's an alluring thing to do. It's, kind of the sexy thing is who can make the lightest West Coast drivetrain or the lightest swerve drive. But that's actually not really the point of a drive chassis. The point of the drive chassis is to get your scoring mechanisms to the place they need to be. The drivetrain itself is not going to get you very many points in a match. You need the other things to be the best they can be. And so focusing more of your resources onto your scoring mechanisms and keeping your drivetrain simple and sticking with something is not going to take a lot of time to debug and fix is a huge deal. A good counterexample to golden rule number 3 is actually 1678's 2008 robots. This is right before I joined. If you want to go to the next slide really quick, this robot was for a game where part of the game was driving around and scoring laps. So actually your drivetrain could score some points this year. But 1678 designed this robot that had 3 wheels, 2 in the front with Ackerman steering, and 1 powered wheel on the back with 4 motors. And if you can't see from the picture, there's 4 motors in the back and a battery strapped above those 4 motors and the 2 gearboxes that those 4 motors go into. So that battery was actually like a foot off the ground, and there was only 1 wheel on the back. So every time this robot took a really hard turn around a corner on the field that year, it would roll over. So it was like the shortest robot, but it was also the tippiest robot because it wasn't a standard drivetrain design. They came up with it that year. It used these potentiometers that weren't very reliable. So there were a lot of problems with this brand new drivetrain they designed. And honestly, they would have scored more points probably if they had just built a standard tank style drive that wasn't going to flip over on them every match and practice with it. But, focusing all the attention onto the drivetrain to do this custom drive was not the move. So a proven drivetrain could be a swerve drive if you have a ton of experience with it, and swerve drives are becoming more and more common. And I know people ask about swerve drives all the time. And yes, 1678 has been testing them, and maybe we'll use one in the future if all of our testing pushes us to a point where it's going to be better for autos and in-match driving. But it has to be something that you're familiar with and that you can build in a matter of days rather than a matter of a week or a month.
So when it comes to mechanism geometry, it's really important that we stick to our golden rules and we try to keep it all simple, where we minimize the degrees of freedom. So we don't want a lot of moving parts. That's more things that can break. We want to keep things rigid. We want to keep things structurally sound. And like Mike said about Rare Cab in 2008, having a low center of gravity, having your motors and your battery as low as possible makes it so that your robot's not going to tip over. If your robot's upside down, it's not going to play for the rest of the match. And so we need to make sure that we don't overcomplicate things and plan for that when we're creating our robots, that heavy things go on the bottom. When it comes to symmetry and staying inside the frame perimeter, these are all things to make sure that we're not overcomplicating things, and that also that things don't break outside the field. Robots are ramming into one another. We want to make sure that our intake, whatever we're grabbing that year, doesn't get smashed because a robot was playing defense on us. We need to make sure that what we are putting outside of the frame perimeter isn't going to break when it is out there, and we need to make sure that it's able to come back in when we're not needing to intake something.
So talking a little bit about mechanism movement, and really in FRC, we're provided two primary options for mechanism motion. The first one is utilizing 12-volt DC motors, and the motor game in FRC has actually evolved a lot in the last couple of years. We have some really smart brushless motors on the market now, including the Falcon and the Neo that are head and shoulders above what we had when I was growing up in FRC back in the mid 2000s. But there are quite a few choices for motors that teams have to use. There's a number of different off-the-shelf gearbox options, including planetary gearboxes and spur gearboxes that are also super helpful for mechanism design. So there's not a lot of reason to be doing custom gearboxes in most of your applications because there's so many great off-the-shelf options. But when you're thinking about, do I use a motor or do I use pneumatics, which Austin's going to talk about in the next slide, if you're looking at using a motor, there's a couple things to understand. You do get more power generally with a motor. It depends on which motor you choose, but especially if you're using one of these newer brushless motors, they're packed with power. So the power per weight ratio on a motor is going to be generally a lot higher than what you get through pneumatics. You also have the ability for like variable movements. So for example, in this picture of the 971 robot, those claw, the angle of both the upper and the bottom half of the claw are controlled by their own set of motors. So the claw was able to loop around left and right, but also open and close. And so there were a ton of very sophisticated controls that you could do with that specific robot because they had a motor and gearbox for the upper claw and a motor and gearbox for the lower claw, and they could adjust their shooting angle to very precise angles depending on what tasks they were doing. But the flip side of that is you end up having to put more investment into the software and controls for something like that. Now, granted, a lot of the brushless motors now have internal encoders, which makes those controls a little easier. But if maybe it's maybe it doesn't need that much power, or you don't have the budget to buy a million Neos and you need to be using a simpler DC motor, you're not a brush DC motor, you're not going to have that internal feedback. So you need to have external sensors that can detect the position of your mechanism. So that adds an additional layer of complexity. And so pneumatics, which I'm going to kick over to Austin, may be a better choice depending on the application that you need power for.
So when it comes to pneumatics, it's really important to know what their application is for. It's really just if you want precise, consistent linear movement, and that is going to be the same every time. So when you are using a motor, you're able to have that variable change, and with pneumatics, you're not going to be able to. But pneumatics are often light; they're small. You can fit them into, right above your wheels. You can fit them in tight spaces that you wouldn't a motor. You don't need a gearbox. However, you're going to need a compressor. You're going to need a bunch of storage tanks, especially depending on how heavily you rely on them. So it's really important to sparingly use pneumatics because teams often run out of air in matches, and you need to wire all the pneumatics, and that's another thing to worry about. But it's also important to not be afraid of pneumatics. I can't tell you how many times I've seen a team to be afraid of using pneumatics and try to figure out how to get that linear movement through motors instead. And it's so much heavier, it's so much harder, and you could have just used your free pistons from Bimba every year to do the same exact thing. So There's definitely cons of both sides, but each one has a very specific application. And if you know how to use it properly, you can definitely come up with some sneaky designs that we're going to talk about later in the presentation.
Awesome. So jumping to another important element of mechanism design, this is in particular for intaking of game elements or intaking of, so intaking of game elements. We call it the acquisition zone. What that really means is what's the effective intake area that your robot has. So the acquisition zone is defined by basically the limits of the extent of how wide you can pick up a game element. So the purpose of increasing the acquisition zone is to decrease the difficulty placed on the driver for acquiring game elements. The most common way that this comes into effect is for things like picking up balls off of the ground. And rather than having a single wheel on a small shaft that you need to line that wheel up right with the ball and you have a ball's width gap in your bumper for the ball to roll through, instead, teams will have a larger gap in their bumper, or they won't have a gap in their bumper at all. They'll go over the bumper and they make the intake the width of their robot to allow for a wider acquisition zone. I think this gets missed a lot by teams. I think last 2019 was a good example of this, where we had to pick up both these hatch panels and we had to pick up the orange cargo balls. So 2 different game elements to acquire. That adds the complexity. And so when teams were trying to do both, they sacrificed some of their intake's effective acquisition zone in order to be able to grab both elements with whatever various mechanisms they had. What you found last year especially was teams that sacrificed on the acquisition zone had a much harder time picking up the game element, because the smaller you make the acquisition zone, the more work your driver has to do to get that alignment just right to acquire the game element. And you can imagine that, especially if your robot is 30 feet away from you at an angle and you're driving sideways and you're trying to pick up a ball, if you're not dead on and you have a small acquisition zone, your bumper's going to hit it or you're going to miss it completely. The way I like to think about it is, imagine that you're trying to direct your buddy who has a blindfold on to throw a dart at a dartboard, but you can't view straight on with what your buddy is aiming at. So you're trying to get him to aim and you don't have any line of sight to where he's throwing the dart at the dartboard. You can imagine that it's going to be it's going to be difficult for you as a third party observer to aim your friend as they're aiming at the dartboard. And so that's a lot what it's like to have a robot with a small acquisition zone. You're trying to hit this small target with a mechanism that's 30 feet away. So by focusing some design effort into increasing the acquisition zone, you take that burden of responsibility off the driver, and that's going to mean your driver is spending less time chasing game elements around the field and more time picking them up and scoring them.
Yeah, so that brings us to golden rule number 4. So we were just talking about acquisition zone, and there's different kinds of intakes, but especially when we're talking about balls or things that were able to slide off the ground, rolly grabbers. So anything that has a wheel or the urethane tube, anything that's able to spin to grab it and then pull it in. It's really important that we talk about, we touch it, we own it. So anything that, any game piece that our intake touches anywhere in its acquisition zone, it's going and directly into our robot. So it's really important, especially in these games now, that we have a way to pick up if the intake grabs it from the side relative to the robot. So in the picture that we have, that intake was able to grab the ball from the side of the intake. It centered the ball and then brought it back into the shooter. And so this helps increase the effective acquisition zone for our drivers, because we don't need to even grab it head on anymore. We can be a little off-centered, and it's still going to center it for us and bring it into our robot. If we had something similar to 2019, where people used the claws or the Velcro to try to grab the panels, you had to grab it very precisely and then very precisely score it. If you have something that it's able to grab it a little off center, and then as a portion of that mechanism centers it for you, it makes scoring a lot easier. Same as we want to keep our robot simple, it's sometimes a little bit more effective to design something maybe a little bit more complicated to make driving much simpler, because that's definitely the limiting factor in every match.
So I think these pictures are up here to demonstrate that. If you go to the next slide too, this is, I think, 10 different 254 robots, and all but one of them have rolly grabbers on them. The only one that doesn't have a rolly grabber is the robot in the bottom right on this slide that's holding the tube. And that robot's the only robot to ever not win the Silicon Valley Regional. So I bring this up every year, not to jab at 254, but to highlight the importance of rolly grabbers. All right, we can go to the next slide. Can I talk about this one, Austin? Is that cool?
You're good.
Awesome. So device robot alignment. I think this is related to acquisition zone, but it's a little bit different. So rather than acquiring the robot, a lot of times there's specific field elements to align to for different tasks. So I'll give a couple of examples here. The scoring towers in 2019 that you put the cargo and the hatch panels on, or the goals that you need to shoot the frisbees in 2013. So it's important when thinking about robot alignment to think about what's going to be the quickest way for me to line my robot up for scoring. And the answer isn't always just slap a vision camera on and use the retroreflective target, because that takes a lot of software overhead to get that right. Sometimes you can design mechanical systems to help with this. So a good example is actually in 2017, there were teams like Team 8, Pally Robotics, that had their gear scoring mechanism on a side-to-side slide. And so when they went up to score a gear on the peg, that was kind of a tight alignment task. And so if their driver was off, they could slide their mechanism over rather than having to back up completely and realign, which a lot of teams had to do if they didn't have that side-to-side sliding mechanism. Another example, if you go to the next slide really quick, in 2013, there's a team I mentored that year, 1662, had these two hooks that they could flip up and engage into the horizontal blue bar that you see in that picture there. And when engaged on that blue bar, that robot was in the perfect position to just shoot all of its frisbees into the goal that was about 15 feet away. So rather than having like a camera system and the driver needing to line up or whatever, the driver would just drive straight into the pole. The robot would just like kind of force its way onto the pole, and then they'd sit there, shoot all 4 discs because they had one shot that was calibrated for that specific position. The picture on the left with 423, similar. They were scoring balls into the 1 and the 2-point goal, and you can see how they just, butt their bumpers right up into the fender there to line up their shot. And a lot of teams shot from the fender that year, even though it wasn't necessarily protected. It was a good place to just index your robot into, and then have a pre-programmed shooter position that would turret over to the right spot and then shoot the balls into the goal. So this whole like alignment, how do we quickly line up is an important thing to think about. Actually, another really good example that I don't have a picture of is in 2011. We had these mini bots that we had to launch up these metal poles, and some teams that kind of thought through the problem a little bit more had these large kind of, we called them like whale tail funnels that were on the front of the launcher mechanism. that they would deploy out and ram into the pole. And so if they were off to the left or the right by like 6 or 12 inches, the funnel would center the robot's launch mechanism onto the pole, and then the mini bot would be fired effectively right onto the pole. So that's another example of alignment, and that's actually kind of like a mix of alignment and acquisition zone, because it makes the driver's job a lot easier, right? But thinking about, okay, we need to acquire the ball with the wide acquisition zone, but then we also need to be able to reliably score our game element by having a effective alignment strategy that doesn't just, kick the problem over to the software students every time, because that's not going to be the right answer 100% of the time. Yes, sometimes you need to use vision. We use the limelight on 1678 very regularly, but that's not always going to be the answer. And it's important to recognize where you can design those in mechanically versus where you need to rely on software.
Yeah, I
Cool.
think that a good example for this in past years is always for scoring, that there's always fixed points on the field that you're going to be able to base your alignment off of. There's normally a square field. In 2014, 254 would always butt up against the low goal, which was just a cube, and so that would be the perfect shot for them. They could shoot from other places, but they knew the point of this is that no matter what you do, you're going to grab it. So, or you're going to score just by no driving of you, or no error from the driver is going to be able to change this, because you have a fixed element of the field, or a fixed part on one of the elements that you're able to line up with. I saw teams in this last year, 2020, line up against the I forgot what it was called, the giant tubes in the center, and they were able to effectively do a 3/4 shot into the high goal with lining up, and no vision was ever required. So it's always important to realize what you're able to line up with and what you're trying to line up to. So when it comes to electrical and pneumatics, this can go wrong very quickly. It's really important to stay organized, because if you don't, you just have a bunch of random wires going everywhere, and you're not really knowing what's going to what. You're not able to diagnose problems very easily. So it's really important that we spend the time to do it right, to make sure that if you want to put in the effort, maybe have things color coded, have things going through channels together that have similar uses, or similar locations, so that you're able to quickly diagnose all the wires at once, and it keeps it clear if there's any mechanical or electrical or pneumatic issues of any kind that you need to diagnose, you know where to diagnose them. A really good example of this is in 2019, we had a lot of electrical issues, and it's really important to understand where the problems are coming from. We spent the entire season diagnosing problems that made us die on the field, and we never solved those problems. And so it definitely led to issues with our autos, with reliability, and keeping things straightforward, simple, is definitely an easier way to make sure that everything is going according to plan. And if things are going wrong, it's the easiest way to fix it, because you're able to look at what's going on. Don't make things harder for yourself just because it's easier in the moment.
And talking about the other side of this coin, programming, when we're thinking about strategic design, and especially what you can do in the preseason with your team specifically, look at your programming abilities and try to pack your toolkit with a couple of basics that are going to be important for the upcoming season. The first of these is the ability to have a precision autonomous driving routine. Outside of 2019 that had Sandstorm with like the option to drive manually in auto, every year has had a fully autonomous portion of the match since like 2003 or 4 or something like that. What I find way too often is teams are not prepared to have their robots drive in autonomous. And so, and even if they are prepared for some driving, they're doing a lot of the research and development on how to do that during the build season. And honestly, you don't want to spend your programming time on that sort of challenge. So what I encourage teams to do is take an old robot and get really good at the basic skills of, I want to draw a path that our robot's going to take, and I want it to follow that path. And that's something that you can build up that toolkit in advance of kickoff. Same thing goes for vision alignment. This has become more and more of a standard element of every year. There's always vision targets that you can utilize. Either you need to turn your robot towards the target, sometimes you need to drive at the target or index off the target in some way. So being familiar with the vision system that works for your team, that you have access to and practice with, is another great thing to have ready in your toolkit. And then knowing how to program PID controllers for precise positioning of mechanisms. I'm thinking of things like, arms or elevators that need to go up to various different heights. And how do you control that mechanism to hit those different marks? That's going to utilize a closed feedback loop controller like a PID loop, or there's stock code available on Talons and on Spark Maxes in the Falcon 500 that you can use, but being familiar with those things in advance of the season is also going to be a huge benefit, not only to your programming team, but if your mechanical team knows that your software team is ready to control something like an elevator, your mechanical team could be more confident in building the mechanism like that. And then the same thing goes for, we call it like a bang bang controller. It's a different type of closed loop controller that's a little bit simpler, but teams will utilize often for their shooter wheels, for games like 2020 with the foam balls. So being familiar with that method of control, having the ability to quickly pull these various functions out of your toolkit and utilize them in the upcoming season is a huge benefit, and it takes out a lot of time. And again, time is like the thing that we're trying to optimize for in all this stuff. And we're going to be talking a little bit more later about why some of the other decisions we make are optimized for time. But having these programming skills in your toolkit going into a season are going to save you a lot of time and are going to allow you to build a more effective robot.
Yeah, so in build season, we're going to talk about why it's important to have an accelerated schedule, why we need to finish things early, when setting a schedule, it's important to set our standards so that that even if you miss, you have the time to succeed, even if you're a little bit off. And people always assume that, especially with there being no bag anymore, that you have infinite amount of time. You don't. It always goes faster than you think. Every single year, the team's talking about how it's week 6. I'm like, what are you talking about? It's week 6. So it definitely happens to all of us, but these schedules keep us on track, and it keeps our development moving forward. So in
all right,
week
so
one, sorry,
you're going to go through this? Go for it. Yeah, go.
Okay, sorry. So in week 1, it's kickoff, obviously. So we focus on understanding the game in days 1 and 3, and we all meet together and we talk about the possible designs and possible challenges that we're going to come across. In day 3, we already have decided what kind of drivetrain we're going with, and we're making sure that our drive-based design is solidified. Moving forward to the end of week 2, we're prototyping. We're making sure that our drive base electrical layout is solidified, that we have a plan moving forward. We know where sensors are going. We know where motors are going. We know where the battery is going. We need to make sure that we have our drivetrain done and ready to drive, and we need to start writing code for the mechanisms that we've decided that we're going to move into through our prototyping.
All right, so let's talk a little bit more about that brainstorming session in days 1 through 3. This has been probably, for me, one of the most important parts of this whole presentation, is talking about how you handle that beginning of the season. Now, granted, 2021 is going to be an interesting year because we're not getting a brand new game. First has already told us that. It's going to be a very similar, if not identical, game to 2020. But with new challenges involved, and Frank talked about a little bit that in the beginning of the workshop session yesterday. But in a typical year, the kickoff brainstorming weekend is the most important weekend of your entire season, and how you handle that weekend is going to set the course for your whole season as a team. On 1678, we have 3 specific steps that we go through to structure our brainstorming weekend of kickoff in order to be successful for the rest of the year. Step 1 in that process is reading the rules, and we believe that this is a process that every team member needs to go through. And we have a rules test that every student participates in at the beginning of the year, and at the beginning of kickoff. So probably within a couple hours of the game being released, our leadership team has developed a Google Forms rules test, and then that's distributed to all of our students who have been reading the rules since kickoff happened. And then by the lunch on our first day of kickoff day, we have all of our students who have passed the rules test, more or less. We also publish this rules test, so if you're interested in a rules test that you can distribute to your team, we publish it right when it's available on kickoff morning. So feel free to check our team's social media or Chief Delphi on kickoff morning, because we publish this every year. And then step 2, which usually takes from Saturday afternoon until Sunday morning, is answering the what questions. So what is our strategy? What will the robot do? We'll talk about that a little bit more in the next slide. And then answering the how questions is usually Saturday or Sunday afternoon through Monday morning. Usually Monday is a holiday right after kickoff in California. And the how questions are there to ask, how will the robot carry out this function? So we talked about what we need to do, kind of that strategy questions of what's the core strategy of what we're trying to accomplish with the robot. And then the how is going to be a lot of the ideas for how you accomplish that strategy.
Yeah, so just like what Mike was saying, the whats are what are we going to do? What are the ways to score? What is each thing worth? What is the difficulty? And we assign values of design points. This is from Karthik, that nothing needs, or we need to focus on making things as simple as possible. And so everything that's not necessarily for the game, it's really important that you guys cut that out, because every single thing takes time in your season, and every single thing that you're able to cross off this what list is another thing that you don't need to spend precious time focusing on how you can accomplish that. So every time that you decide to specialize or to focus on one point of the game as your main design of the robot, you guys should be celebrating that, because it's not just something that that is the right thing to do because someone else is doing it. It's what you guys have decided to meet your goals this year, and you decided that you're not going to waste time, energy, and resources on that. A perfect example of this is 2910 or even 973 in 2019. Neither team decided to go for the highest level of the rocket, and both teams easily could have won the world championships. 973 was the world championship alliance leader, and they decided that it wasn't worth the extra time, weight, effort to design something that made it to the highest level, and they were able to use those resources to better focus on what they decided to do. Mike's going to talk about how we decide we're going to do something.
Yeah, so talking about the hows, so once you have a list of the what's, which is every functional requirement for the robot, and this goes down to the level of we need to be able to drive, we need to be able to drive over this bump. Like those are the things that you want to put down on your what's list, in addition to we need to be able to score at this level, we need to be able to pick up a ball from the ground. Those are all what's. But then we go to the how section. And on kickoff weekend, when we're talking about the hows, we break out into smaller groups, and every group is looking at this list of things that are going to be required for a robot this year. And we talk about what sort of mechanism designs could carry out each of those functions. So maybe the idea of scoring a ball into a goal that's 8 feet off the ground is very similar to what we did in 2016. So we have an idea of what that could look like, and we can draw that out, and we could be like, what if we took a lot of the lessons learned from our 2016 robot and put it on our 2020 robot? And you come up with these ideas, and the big thing here is being able to effectively communicate your mechanism designs through quick sketches and maybe a quick Crayola CAD here or there, something that's easy to put together really quickly because time is of the essence this weekend, and then that you can communicate with the rest of the group. And we actually have each of our small groups of students present their ideas to the rest of the team on a whiteboard and or projector. And then keeping things to scale is going to be really important here. One of the best examples I have of this is back when we were sharing our how ideas in 2014. That was the year of the big exercise balls that were like, I think they were 25 inches in diameter or something. They were very large. And I remember seeing a sketch one of the groups of students on our team put together and presented to the rest of the group. And they had a sketch of a robot, and there were like 3 little, what were supposed to be the exercise balls, like stored in the bottom of the robot. And you could tell right away that if each of those balls was actually 25 inches, this robot was going to be massive and completely outside of the rules of the game that year. And so it's important when you're thinking through your design ideas that you're keeping things to scale, you're keeping in mind what your extents of the robot, the maximum extents of the robots are for that season, given the rules. So that's how we kind of talk about the hows. And the goal for the hows section is to have a list of mechanisms that you want to pursue, either going straight to design or going into your prototyping with your prototyping groups in order to validate the ideas that are presented. And then I think we got to skip this one. This one's kind of out of place, and Austin can talk about week 1.
Yeah, we talked about week 1 already. So in week 2, we have our drivetrain finished. We have the entire thing wired, and we're able to test driving. In starting day 8 through mid of week 3, we're focusing on putting our initial versions of our mechanisms together. We never distinguish the prototype and the mechanism. It's just all kind of one thing together. We make iterative designs throughout the season, and so our prototypes get tested, and then we fix them, and then we test them again, and we fix them. And throughout that process, as we're adding functionality, we're adding rigidity, our programmers are making sure that we're able to better test it. So initially it's with a simple test board with a button, and then we use a joystick, and then we have it on the a practice robot, and then we have it on the robot itself. And then we start integrating these mechanisms together. And like I said, we start assembling this on a robot with our initial code base.
All right, and that takes us right into day 29, where so by the end of the 4th full week, we try to have a robot quote unquote finished. But that is not the end of the development cycle. And I think John JVN is a great person to listen to when it comes to iterative design. He has a lot of great insight on this exact topic. But what we try to emphasize is the testing and especially the braking process of our robot, and then fixing those brakes, and then implementing those and seeing if it breaks again, and if it breaks in a different way that we can fix. The goal with this is golden rule number 5, which I say is fail faster. This idea of when you go to a competition and you see a robot that is performing at a higher level than yours, maybe because it's more reliable or it's scoring more points per match, it's probably not because the people that built that robot are perfect and they have perfect insight, and it's just they spent the same amount of time as you. It's just they came up with a wildly more amazing robot. I think what happens more often than not, especially in something like FRC where it's a brand new game every year, is everybody's getting this game brand new. The difference is how fast you're able to fail and how quickly you can learn from those lessons and implement those lessons. So maybe a team that's performing better on the field had more failures in their shop that they were able to identify, and they were able to through fixing their robot through driver practice. And so they don't have the same problems that your robot might have on the field because you haven't discovered all the problems yet. So that failing faster mentality, this idea of, I know even though we finished a robot, it sucks, and we need to figure out how it sucks, and we can only do that by testing. And then that driver practice really comes into play too, because what we find is a robot that may have been designed fairly well can still lose a match because it doesn't have a familiar drive team behind it. And so this idea of driver practice is not just for the drivers, it's also for fleshing out your robot problems, and try to combine the two. Try to do as many driver practice sessions as you can and take notes during those driver practice sessions about what breaks on the robot, so your design team can be fixing the robot problems while your drive team is getting practice with the robot. And both of those are feeding into each other to have a successful machine.
So specifically when it comes to no bag, we're short on time, so I'm going to rush through this. Same as with the normal season, you don't have as much time as you think, just because there's not a specific date that you need to be done by besides your competition. You're always under the gun when it comes to time, especially because you need to have that strict schedule for yourself, as well as this is an opportunity to continually work on your robot after that normal 6-week season, because other teams aren't going to stop. And so it's important that you don't as well, because they're just going to leave you behind.
Yeah, and then another thing, we talked a lot about how important driver practice is, but it's really important to also understand how the game is going to play out. So one thing we do on 1678 is we watch other competitions every year. We do, you can see the picture there, we do a pancake party every year where our mentors and students make pancakes for each other while we watch matches early in the morning, usually like the first week of competitions. And just do your research, like learn about how the game's playing out, read Chief Delphi, watch all the different amazing first content that's out there in the community, and get familiar with how the game is playing out, because the more you understand how the game is played, the more successful you're going to be out in the field.
Yeah, so just as a summary, with preseason, it's really important that you use this to prepare your team for the season. When it comes to drive base, Stay with simple, proven designs when it comes to mechanisms. Don't try to overcomplicate things. Try to keep things simple. When possible, stay structural, and with electrical and pneumatics. Don't overcomplicate things and make sure that things are organized. Build season and competition season, don't underestimate the amount of effort that things take, and make sure that you have enough time to complete these.
Great. Just resources, Compass Alliance, Chief Delphi. Hopefully you've seen them before, but if not, check them out. Yeah. And Helena, do we have any questions?
Yeah, we have one question in the chat. It says, what are your thoughts on Swerve with proven COTS solutions?
So I've been really impressed with the quality of the COTS swerves that are on the market right now. When thinking about Swerve, like 1678 has been testing with a couple different off-the-shelf solutions. I'm going to be honest, I don't know at this point why, especially if you're a team that's never done Swerve before, but even if you're a team that has done Swerve before, I'm not sure why you would ever build your own at this point, because there's so many great off-the-shelf makers of Swerve drives now that do 98% of what you need a Swerve drive to do, and you can buy it and forget it. That, I think off the shelf is the way to go for Swerve drives. I'm interested in what Austin thinks about that.
No, absolutely. I don't think that we're ever going to put in the time to design and test our own, because we're always going to just buy one if we ever decide that, because they're already doing that iterative design on their own. Patrick from 2910 is doing a great job with his, and he's been making new iterative designs every single year, and I'm very excited to see his new models. But I definitely think that the whole thing in FRC, when it comes to in the game or in the season, or even prepping for the season, it's all about time, and that's the most expensive resource you have. And so, even for teams that are strapped for cash, buying these resources or using COTS parts as much as possible saves so much time and effort.
Mm-hmm.
Great, thank you guys.
Absolutely.
And with that, I think we're pretty much out of time. Thank you guys so much for watching, and thank you to the presenters for presenting. And make sure to tune in to the next workshops that are going to be on these live streams. Thank you guys.
Awesome. Thanks, guys.
Thank you. Bye.
Welcome back to the 2020 Capital City Classic. We will be discussing collaborative online design using Onshape with our two speakers, Ben Pochop and Alex Berghardt, and me, the moderator, Juan Muhirwe.
Good afternoon, everybody. My name is... Oh, sorry, Juan. Go ahead.
So first up, we have our first poll, which is which CAD software has your team used the most or in your last build season? And so we would like to direct you to Mentimeter and just follow the directions at the top of the screen.
While we're waiting on those poll results, I'm just going to go ahead and introduce myself and give Alex a chance to introduce himself as well. My name is Ben Pochop. I am one of the mentors for Team 701, and we're here today, like Juan mentioned, to talk about using Onshape for collaborative on-demand design. With me is Alex Berghardt, our design head. Alex, say hi.
Hello.
And so once these polls get rolling, we'll get started here in just a minute.
So far, we have Onshape, SolidWorks, AutoCAD 2001. So far I'm seeing a lot of SolidWorks and some Fusion 360, but for the most part, it's mostly SolidWorks, Onshape, and Fusion 360 that's coming in a lot. And there's a few others like AutoCAD and Autodesk, but the biggest ones seem to be SolidWorks, Onshape, and Fusion 360. Today we'll be mostly talking about Onshape and collaborative design in there.
Awesome. So that's good. SolidWorks and Onshape are very similar. In fact, they were created by the people who made Onshape used to work at SolidWorks. So a lot of those features that you're used to are going to carry over and be the same for those of you who are there. We still use Fusion 360 on 701 for portions of our projects, and we'll talk about that a little bit later in the presentation. Let's go ahead and hit the next slide, Juan.
So the next poll question we have is whether or not your team is able to work in the same building currently. I think that it's really important because we're currently in a pandemic to know, like, if you're working fully inside with your team or it's remote or partial.
Yeah, and we're in the same boat here. So it looks like most of the people who have responded, we are not allowed in our shop at all. I'm here streaming from the shop today because that's the quietest place I could find, but I'm not allowed to have any students on campus with me. And so one of the things we want to talk about today is how you can maintain your momentum, keep doing work, continue building and iterating on your design aspects, working with your robot, even though you can't get to your shop where you have your CAD computers or you have your server set up for your part sharing and all those things. We're going to talk through how Onshape allows you to continue with your trainings, keep your rookies engaged and onboard them, and as well keep your upperclassmen involved and working through design challenges, even though they may not have access to the same hardware they would if you were in the shop. I think that's all the responses we're going to get here. So we skipped a couple slides, it looks like. Yeah, back one more. There we go. So again, we're going to talk here today, and we're going to start off with that high-level 50,000-foot view. I think I saw one response that said your team was currently using Onshape, so this will be a little bit of a recap for you. But for everyone else who was coming from SolidWorks or Fusion or AutoCAD, I'm assuming that's Inventor, you're going to see kind of what the basics are here before we get into the collaboration tools. So Onshape is a collaborative online Google Docs style tool. Onshape gets used, and you can use it hardware agnostic. This is one of my favorite features of Onshape. I have my phone, and I will regularly open up the Onshape app on my phone and check parts for my students or take a look at their designs, look at drawings, and I can do that no matter where I am or what I'm currently doing. It runs on Chromebooks. I know a lot of schools have given out Chromebooks to their students for remote learning, and this gives you the option of doing CAD even though you can't install software on a Chromebook or you can't install software on a district provided laptop. You can still access CAD through your browser. It's the Google Docs of CAD. That's my term for it that I use a lot. And there's a good and a bad side of that, right? If you're coming to Google Docs from Microsoft Word, you're going to see that there's a lot of features that are not quite in the same place or not necessarily the way that you want them to run. And you're going to get 90+% of what you want out of it, but there's still some really high level advanced stuff that's missing. And you're going to have that same problem in Onshape potentially. Now, I have not hit that issue with Onshape and FRC. We are able to do everything we want to do with it, but that is a possibility. The other part here is that it's automatically updated every 3 weeks. They release an update. So you're not waiting for the next year or next release cycle, SolidWorks 2021, 2022. Every 3 weeks, you're getting new features. Onshape is not CAM software, finite element analysis software, or rendering package. It doesn't work offline. These are some downsides to it. You are really good. It's a great parametric modeling tool. But if you want to do renders, you want to do designs, you want to, oops, sorry, clicked the wrong button there. You want to create a render of your package, do some CAM, run a finite analysis or element analysis, stress analysis, you're going to have some issues there because those aren't built into it as a feature. There is a store where you can get some add-ons that do have those capabilities, but those add-ons aren't always free. So our workaround for that is that we take our files and we do our design work in Onshape, and then anything that we need to do beyond that, our CAM, our stress analysis, or our rendering, we just drop it down into Fusion through a step file, and we're able to run those analyses that way. We're going to hit 4 kind of key topics here today about sharing and collaboration. Onshape teams, we'll talk about those a little bit. We'll also go through kind of a sample workflow that we use on 701 to give you some hints there. And then at the end, we'll talk about branching and merging, which is a little bit more advanced of a topic. If you want to follow along, I think Juan can put this into the chat. This will take you to the Onshape document or a Google Drive folder, I forget which one is which, that we are using that has the presentation and everything in it. So Onshape, why would you want to use that for sharing and collaboration? Aside from the fact that we're in a global pandemic and 80% of you aren't able to be on your in your shops right now. There's also the benefit that you have mentors that potentially get stuck working late or can't make it to a meeting for whatever reason. They're able to log in when they get a minute or a chance, and they can provide you feedback that way. You have a chance to do online training and feedback, which Alex is going to talk about here. And we'll talk a little bit at the end here about ways that you can use this when you're back on campus. 701, we've been on Onshape fully for 2 years now, and we're not going back. So Alex is going to jump into our Onshape presentation here with me, and we're going to show some demo things here. So you can see my screen here, and here is Onshape, and I can see, just like in a Google Doc, hey, look, Alex is here. Hi, Alex. And if I'm working and we're doing some things left and right, I've got my general user interface, just like any other CAD software. Those of you coming from SolidWorks, if I push the S key, I get my context menu, right? All your features, your favorite things are there. But I can also give some feedback to Alex, whether we're meeting at the same time or not. Alex is working on a part and he sends me a message and says, hey, I finished this up. Can you review it? I can leave comments directly on that part and say, hey, Alex, you might want to look at this. And not only does it show Alex that there's a comment for this part here, but it also shows him, if he clicks it, the view and highlights what I wanted to talk to him about. So that's a benefit here. Gives him a chance. You can see a comment here from last year from Tony, who was our design head of the year before. And so comments are a way for anybody to interact, get some quick feedback on small things, and you can do that at any time. We're also going to talk today about follow mode. So Alex, if you can go ahead and just start moving around and showing some different things of your screen. So I'm following Alex right now. He didn't have to do a screen share to load up to this presentation. He didn't have to do anything on his end. I can see his mouse clicks. I can follow what he's doing. And if he wanted to go ahead and edit a part here, I can see his sketch, I can see his changes as he's making them live. And so if you're doing remote training, a lot of what we've noticed, both me as a teacher and Alex doing the training for our students, when you're running Google Meet and you're running online CAD software and your students are, your team members are working on computers that are of varying quality and work power, sometimes doing a screen share just causes everything to lag and bog down. And so by doing follow mode here, you can see what they're doing and follow along, give them a hint or a help, and also allow them to show you what's going on without adding that extra strain on your hardware. Additionally, if I wanted to show Alex something specific and we're talking through, he can follow me. Go ahead and follow me, Alex. And you'll get a little notification. And I can show Alex, hey, look, no, I'm talking about this part right here. And there's no long-term effects of, okay, now rotate 40 degrees to the right and go to the back view and isometric. I can take and zoom and show him exactly what I want him to see. We also have the benefit here of multiple people editing at once. So we're going to go to this simultaneous work slide together, Alex and I. And this is a piece of 2x1 aluminum tubing. Hey, look, everybody knows what these are. And we took 1/4 inch clearance holes every inch along the top face and bottom face of our tubing, as well as a pattern here as well. And if you're working together on a part, a lot of times in other softwares, you have issues with resolving connection issues or problems like I did this and you did that and they conflict. So what we're going to show you here is Alex is working on the top. Oh, sorry. Go ahead, Juan.
So how does like this help with collaboration, mostly during remote learning?
Yeah, so during remote learning, right, I can show Alex exactly what we want to do. This is a little more geared toward this particular part. You're working together on a part. Alex and I both want to make this part. We want to get it done really fast. So Alex is going to put a hole pattern across the top. I'm going to put one here on the side face. And there's no resolving issues. There's no problems going back. If I wanted to demonstrate for Alex, right, he can still see me here. He can follow along with what I'm doing, and we can make those changes together. So I'm just going to put a simple hole pattern here. And at any time, if I wanted to talk through what Alex is doing on his end, I can go look and see, hey, look, here's where he's at on his part. Tell him his hole sized incorrectly or he has a problem there. So as you're training your rookies or you're working through a design with your other teammates, you have that option and that ability. This is, again, a very simplified example of what we're looking at here. This isn't something you would necessarily have to worry about. Obviously, creating 2 hole patterns is something that's really quick and easy to do. But you can see that when we're done here, assuming I can click the right buttons. When we're done here, Alex has his part done. Hopefully he's finishing up here in just a second. I have my part done. And we were able to do that together at the same time. There's no versioning, there's no saving our Fusion 360 files and dealing with issues with the overwriting of the correct or most recent version. I can change my part and his part independently of each other, and we can work on those at the same time. So you get this ability to collaboratively design a part together. This is stupid simple, but you can see if we're working on building a frame, Alex can work on the width portion of the frame, I can work on the length portion of the frame, and we can start putting this together really quickly together at the same time. We're also going to talk a little bit later on about branches, which you can see up here. I just want you to know that they exist at this point, and we'll come back to them at the end of the presentation. So the next thing we're going to talk about is your Onshape teams. We had a step here where we were going to do a volunteer, but that didn't work out. So Onshape teams and building a part library. And you can see right here in my share settings, I've got Team 701. Everybody in that team can edit this document. I'm not actually the owner of this document. Someone else made it and I've added to it. So I can do all these different settings, and then anybody with the link can view it. So if you're working with a team from another part of the country or that's not local to you, or right now a team from anywhere because you can't interact with them one-on-one, you can share these links over and show them different things. You can give them different permissions to access your documents in different ways. 701 is our team though. And so by creating a team, I can just with one click or one button type, share that document with everyone in my team. And building a team is really simple. You just go here to teams, you create it. You can give it a description if you'd like. And once you've done that, you just add some emails and you populate that team. And now every time I share that document with the team, I can share it with everyone. So as your number of people on your team or your design team grows, it makes a lot of sense to do it this way rather than trying to share that document individually. Because if I'm just sharing with Alex, it's very easy to hit share and talk to Alex. If I am trying to share with the 30, 50 members of my team, then it makes a lot more sense to use that Teams feature. Using the Teams also gives you the ability to build out your part libraries. So right here is our library that we've built over the past year, and we're still working on this. You can see you've got your different components, right? Just like you would in any other CAD software where you've imported some step files and we've converted them into Onshape files so we can drag and drop them into our assemblies where needed. And because we set up our team and shared those folders with the teams, everybody in the team can link those documents into an assembly. I'm going to turn it over to Alex here for a couple minutes to talk about online training and what he's learned. He's been leading that aspect for our rookies.
All right. So the learning curve is just like every other CAD software. It's pretty steep if you've never used it before. Adjusting to Onshape is relatively easy for people who are already proficient with other software, though. And because it's a little more niche than some other programs, it kind of assumes that you already have some basic understanding of CAD, and so it's not really the perfect way to teach rookies. So the Learning Center is a feature that Onshape has, where it's just a bunch of videos and instructions on how to do stuff. Most lessons have videos, and it makes it easy to follow along. But as I said in the last slide, it's more geared towards reviewing, not teaching people who don't really know how to do it. So because of this, it's really important to check in with rookies to make sure that instead of just watching and reading the instructions, they're actually understanding it. And even if they do understand it, checking in is also helpful to review it and solidify it, because a lot of the things that they learn through these are the foundation of CAD.
Before we move on, Alex, did you want to show some of those training parts you've done?
Oh yeah, but I think you need to screen share.
Which one do you want to start with?
I'll start with this one. So this shaft, it's 1 inch thick instead of ½ inch, which is what we normally use. So that was because we told them to make a shaft that was ½ inch, and instead of dimensioning the opposite sides, they dimensioned it from the inside. So the way that we solved this issue is I think we used screen share for this one, and we just showed them what the correct sketch should look like, and then they fixed it for themselves. Yeah. And then the next one, this one was more difficult to explain because there were a lot of faces, and to prevent them from just copying what we were doing, we did it all the first time, and then we did it again, and then we had them do it after we had completely finished it.
Awesome. So the next step here is then, right, eventually, ideally, at some point, hopefully sooner rather than later, we're all going to get back into our shops. We're going to come back from working in our online collaborative environment to seeing people more often. So what we're going to see there is you're going to be back in your shop, and there's going to be some reasons to maybe continue on with what you've been doing before, where you're working on your Fusion or your SolidWorks, and if you're want to keep going with that, that's great. I'm going to talk through some benefits that happen or can happen now if you come back to your shop and you want to keep using Onshape. So a couple of those have to do with your production or your manufacturing team. And what happens, or what we've noticed, is that we print drawings. We print a lot of drawings. We print a lot of reprints of drawings. Drawings get hurt, drawings get torn, drawings get messed up, drawings are wrong, and they have to get rebuilt. And so what we've found is that we can use Branch and Onshape specifically for the manufacturing team, and they can see this part, right, on their phone or on a computer without hunting someone down, and they can hide aspects of it, and they can look at it and explode it out on their own to see exactly how it's supposed to go together in a 3D space, whereas a drawing is more just a two-dimensional aspect. They can get dimensions that they need. If the dimension was missing on the drawing, your designer missed that part, or it's changed, or it's been modified, they're able to see those things, and they can do all that without hunting down someone from your design team and asking them a bunch of questions. It gives them the power to find those answers on their own, which leaves your design team working on the things they want to work on. Remote collaboration, honestly, in my view, is still going to be necessary even if schools are open in the spring. We're looking at, in our district, being told that even if we're meeting on site, we're having to do reduced capacity. So our manufacturing team that runs our CNC machines and our tools, they might be allowed to be on campus because you can't do that from anywhere else. But our design team, our programming teams, they can work remotely, just like you're seeing in industry right now. And so you're still going to have some type of remote collaboration aspect you're going to have to do. Additionally, you might have a student who's sick who still wants to come in and do some work. And that's a big no-no now. You should not be coming in when you're sick. I know I've done it. I haven't felt great, but there's been important stuff to do and I've come in. And so now you can still, even if you're sick, stay home. You can log into your Onshape. You can have that remote meeting. You can work on those tools together and get those things done. We're going to finish off here today with our branching and merging before question and answer time. And branching and merging is, again, another method here to work together, to collaborate. Here's a quick pros and cons list, and this is by no means exhaustive. We're looking at just a couple examples here of some things that are good and bad. You can quickly, right, tie a bunch of ideas without having to worry about how they interact with each other by making some branches. You can, one of the things we like to do or have added in is adding a render branch. We paint our robots dark green and black, which you'll see in a minute here makes it really hard to see them in the CAD. And so by making a render branch, you can put your high quality models of your electrical components. You can put your colors of your robot in there and have that branch separate so that you can work in your two different aspects. The simplest form of branching and merging is very easy to do. Doing it at a higher level, just like if you have worked with or have heard anybody working with GitHub, the more advanced features that you're using, the harder it is to implement. And just like with GitHub, not everyone can do a pull request in GitHub for programming. You need someone who has that ability to lead and manage the merging process and deal with any potential issues that pop up. You don't want just anybody to be merging things back in. So we're going to talk through a quick branch and merge demo here. So I've got my branches here, and Alex, you're still in main?
Yeah, I'm still in main.
Okay, so Alex is still here in main, and I'm going to go to this branch that I called Fenrir No Color. Fenrir was our robot from last year. And if you look here, where's my drive base file? There it is. Here's a drive base. Here it is in main. And again, right, those dark greens, the blacks, it's kind of hard to see where those holes are, what pieces interact or where, and it looks really good, but it's not the best for usage. And so Alex, while I'm in here, can you jump into this superstructure parts and delete out this floater?
We have a question asking, what have you found are best practices for documents, studios, assemblies? Should you have lots of tabs, single tabs, or multiple links?
Yeah. We have lots of documents, lots of tabs. I can come back and I'll show you our library here just as while Alex is working on that. So our library, again, it's broken down. There's a lot of folders, and in those folders are individual documents. We have some of these that have tabs. Simple electrical board components, for example, has different tabs linked in. So that gives us the ability to kind of work in it. By having it all in different documents, you're going to run into processing slowdowns. Is not the best method that we've seen that has kind of caused our assemblies to chug. If you have your links or your link documents and your versions, I think it was Onshape posted a update recently that said the best practice for that, you're going to see better performance.
Have you had any issues with ownership? Should all team members give ownership to the team account?
Ownership. So like people, yes, we have had issues with ownership. So here's our library again, right? And this was our design head last year, actually our director of engineering last year, Will, and he built these libraries and kind of made them. And one of the things we ran into was that students who were adding files in couldn't delete anything because of the way that the folders were set up and the permissions. They weren't able to delete anything. They were able to move things around. So we had to make this trash folder for them to move it. So there are some issues there that you can run into. We haven't had any issues of people opening the documents and people who aren't supposed to open documents opening documents. You do have that ability to change your permissions, right? Copy, link, document, export. Those are the basics. You can change how those are given, who can do what. We kind of have as our general format or rule is that the robot and all the parts that go into it. Let's see if I can find. Here's Finner. Here's our robot from last year, and you can see these document folders get pretty hefty. A lot of different stuff going into them, and these are just shared out mainly with the whole team. We also gave it some other permissions here for anybody with the link, or these are two add-ins that we tried to link up to, but mainly that giving that permissions to the team lets everybody see it, manipulate it, and do what they need to. Alex, are you done?
I'm pretty sure, yeah.
I'm pretty sure you deleted that part. So you can see here, right, I'm in a different branch than Alex. I'm in the no color branch where I've taken these components and I've gotten rid of the dark green color to make it easier to see what's going on. And I didn't delete this piece. This piece is just kind of floating in space. I think it's attached to something in the final assembly, but I'm not 100% sure. If I go to Alex's branch right here, that piece is still there.
I deleted the wrong part. I gotta redo it. Okay, it's loading. It should be gone in just a second.
So that part's going to disappear here in a second. And I'm just going to show you real quick. You have your two branches, and I made my branch with this versions and history, and you'd create a version, and from each version you can right click and create a branch to create a new workspace. Super simple, doesn't take a lot of work to do. And what you can do is you can compare these, right? So I can look at my two workspaces and see what's different between the two of them. It'll tell me assemblies. It doesn't like to compare those. This tab doesn't exist in one versus the other. Same thing for this one. They were slightly different. It found some differences here, and if I look at those folders, it'll tell me what the differences are. In the sketch, something changed. The assembly I can't see, and then here in the superstructure, which is the file that Alex just modified, in mine, it has that floating piece, and in Alex's, it's gone. So I can compare my differences right here. And again, this is a simplified version of this. This is not necessarily the utmost ability. I just wanted to show you quickly how you can kind of compare those things. And so now that I'm here and I've seen those differences and I'm happy with what they are, I can take this and I can take my branch with no color and I can merge this back into the main branch. And when I do that, it merges my colors back in. Wait, did I do that wrong? Merge. Oh, sorry, I did that backwards. Merges my colors back in, and it gets rid of that part. So both of those changes that happened in different aspects get carried over and work back together. Now, again, simple, but you can envision a place where this is a bracket for part of our climber mechanism up here. You have 3 or 4 different teams create a branch and work through some different iterations of this climber. And maybe one comes up with a really good way to connect it to the base frame. Another one comes up with a really good way to connect it up here. You can merge those changes back together and have them carry over and attach to each other, which is kind of nice. You don't have to do a bunch of assembly deletes and adds and moving things around later on. My next piece here is going back. We've kind of zoomed down and talked about a bunch of features in Onshape. We're going to go back up a little bit to a higher level. And I just want to give you an overview of how we do things on 701 for some sample stuff. And we'll talk a little bit about the things that we like and don't like about Onshape. And then we'll be question and answer time. Alex talked yesterday at the mechanical design presentation. And so if there's any kind of questions on this, he can handle those. But basically, we take our parts and we go from Onshape, where we do our collaborative work. We build those parts, we build those assemblies. We're creating those drawings in groups. We're working on those things in a collaborative way. And once they get finalized, we know this is what this part is going to look like. We can export it out through STEP and take it to Fusion, where we do our CAM and our rendering. This gives us the ability to, when we're done, right, we know at this stage when we're exporting our step files that we're not making changes to this part. And if we are, we're going to have to remake it anyway. So at the export step file part, it's kind of final, and we know what's going on there. Before this, we have a bunch of changes, and we want multiple people to be able to input in those changes in that Onshape section. Once we go to the export, we don't need the collaborative aspect anymore, because creating a CAM file is a kind of a one-person job. Creating our rendering is a team process, but they only do things individually one at a time. The last thing is things we like and don't like about using Onshape. So we really like the collaboration. It's great. I love it. Being able to tell someone, hey, let me log in and look at exactly what you're looking at without having to email a file back and forth. Feels a lot like when we're in the shop and a student asks me a question and I just go over to their computer and look over their shoulder. It's really nice. No hardware requirements, essentially. Like, you can run this on, I ran it on an 8-year-old Chromebook. I've run it on a Raspberry Pi. Granted, big assemblies start to have issues, but you can do a lot with very, very little hardware power. And the phone app is nice. More so for your mentors probably than anyone else, but the ability to see comments, chime in, add responses to quick questions, no matter what's going on, is really nice and able to be able to do. Drawings, your basic features, extruding, revolving, sweeping, all those things are the same. Assemblies are basically the same. There's not a lot of differences here in your basic kind of core functionality. And then again, that dislike that we came up with is when you're running Onshape and some video conferencing software, it does cause stuttering. It can cause some problems with your computer slowing way down, your graphics getting chunky on the Onshape side. And so it's nice to be able to do that follow mode to avoid those issues, but it is something to be aware of. Did a little bit of research in preparation for this, not an infinite amount, so this could be, there's might be some stuff missing here. But other choices, there are some other things that exist, right? SolidWorks, I believe, is working on an online version of SolidWorks, and it's in beta right now. I don't know that it's available for FRC teams or students to use, but it is something they're trying to bring online. Fusion 360, again, sort of is the same, has some differences. You have to download Fusion, you have to run it as a standalone software, you have to sync your files back and forth. So you're still kind of in that check-in, check-out mode on your software files. You're not seeing the instant updates. And that's my last slide before Q&A.
So if you have any questions, just put them in chat.
I see Jim's got a few here. We did last year successfully convince one of the rendering companies to give us, hey, I didn't know that, Robert. Good to know. Give us some rendering time on their servers to be able to use that add-in. And the students kind of did a comparative analysis on it and found that using Fusion and downloading the files and running it in Fusion was almost easier than using the online built-in add-in tool. And so we didn't end up doing that. I'm just going to go down the list here, Jim. Follow mode doesn't work when you're in a sketch. That's somewhat true. What happens is if you make a brand new sketch and you have nothing in it for the very first time, follow mode, you won't be able to see the sketch. But once that sketch has been committed and they've finished it once, and then they go back in and edit it, you'll be able to see the sketch. Parts and assemblies with respect to the origin planes. So I think I see what you're talking about, Jim, and we'll see if this. I'll come back to your origin assembly question in just a second. I don't know if the education version is worth it, honestly. I looked at it right now. Actually, I think we're past the cutoff date, but I know they were offering it as a free update for schools for a while. I don't know when that cutoff or when the date was. It was in November sometime, but the extra features that I've seen, there was a couple that I really, really liked and a couple that just didn't work for our team. The educational enterprise version comes with, the big one that I liked was the ability to track your users. So you get a dashboard as an admin to the panel, and you can log in and see who's been spending how much time in what aspects of your robot design, which would be really helpful for seeing who's doing what, from especially if they're working from home. The other things that come from enterprise releases mainly are have to do with version product release levels. So taking things from in design to in manufacturing to full release and having those tags within your enterprise level for that are the other things in enterprise education. There's more, but I don't know what they are because I didn't look that closely at it because it was a lot of money for not a lot of extra functionality, in my opinion. So looking at an assembly, and let's see if I can get my screen share back up here. So I'm here, I'm in a brand new assembly, Jim, and I think I'm trying to translate your question from the chat. Hopefully this works. You want to get this to the origin planes of your part or the origin planes of your assembly. You've got your origin here and your assembly, and your front side planes are all there. And you can attach these parts in. If I just click here in this area, it automatically attaches it to the origin, and that it's going to be oriented that way. Or I can place it wherever I want. So if I go like this and I drop that slide in right there. And I can then do a fix, or ground is the other term that's typically used in CAD for this. It's now locked origin to origin on this piece. So it's going to be laid out that way. If I want to rotate it, I have my rotations here, 90 degrees, and now it's rotated. It's off a little bit of my origin, but I can do a mate connector fastened here between the origin and that part, for example, and now it's locked on the origin and it won't move. Hopefully that answered your question. So you're looking for the mass properties here, Jim? Is that right? And you want it to be above the origin. So if you're attaching this assembly to your origin again, let's see. For example, this base rail, if I go in here and I attach this to the origin, it's going to shift that over. It's going to take a second to solve this here. Let's try that again. Origin to that piece. Oh, something's grounded. There we go. So that's origin is attached there at that point, and you want to have it with a different location, right? Respect to the carpet. You can edit these fastens with the offset, and you can move them around how you want to go. So if you wanted it to be above the origin, I could make it 12 inches above the origin. 12 inches. And now everything's shifted up by a foot. Any other questions? I am not sure on that question, Jim. Sorry. Looks like you can set your reference frame to be different things. So you could pick part of your, change what connection you wanted to have there. But yeah, I'm assuming it defaults to the origin. And just in case anybody missed it, Robert Green pointed out that Fusion 360 does now work on Chromebooks. So that's news to me. I had not seen that yet. So that's great for those of you who have Chromebooks that you need to use for your school district.
Is there any final questions? If not, thank you and have a nice day. This is the ending of our panel.
All right, welcome to the Vision panel. My name's Gabriel. I'll be your moderator today, and I'm joined by 3 wonderful panelists, Anthony, Kevin, and Lyra, who will be giving some thoughts on vision. So Anthony, take it away.
All right. Hi, I'm Anthony Demetrescu. I'm a mentor on 3476. I've been a mentor for 4 years. I've been the lead. I was a member on Code Orange for 4 years, and I'm the lead programming mentor 4 years running. So I'm just going to walk you through how Code Orange does vision, and yeah. So first of all, the hardware, we use bright, very bright 1 watt LEDs using a constant current driver. We use a USB camera that's PCB mounted with interchangeable lenses for varying distance applications. We use a Jetson TX1 with an Orbity carrier board to shrink its footprint down to something that we can actually fit on our robot. The Jetson Nano is cheaper and it has comparable performance, so that's an option if you're looking for that. All right, so overview of the vision pipeline. So obviously our camera transmits image data to the Jetson so that it can process the images, does that via USB. The Jetson then processes the images locally and then sends a very small amount of target data to the RoboRio over UDP, which Ethernet and then Wi-Fi through the bridge. The Jetson also sends a live stream to the driver station for the drivers to use. And the RoboRio can send camera exposure settings back to the Jetson via UDP. All right, so the first step in image processing on the Jetson is gross filtering. So the way we do all of these image processing steps using functions in OpenCV, which is an image processing library. So the first thing we do is we convert the image to an HSV image, hue, saturation, and value instead of RGB. So first of all, we want to threshold the image to only get the parts we care about. So because of our green LEDs, the target, the retroreflective target, is very bright and green. So we want to look for a green hue. We want to look for a very saturated color, so as opposed to gray. So very green as opposed to gray. And then a medium to high value because, again, it's very bright. The output to this is an image that's all 100% or all 0. It's a binary image. The next step we take is a morphology operator. So we use opening, which first gets rid of, shrinks all the white pixels in the image, and then expands them again. And this gets rid of little tiny granular noise. It's much faster than using a blur kernel, and so we can get rid of a lot of little tiny noise we don't want to deal with. The next step is target extraction. So we use another OpenCV function to find contours, which is the outlines of the various blobs in the image. And then we want to classify these. So we're going to calculate a number of different metrics about these blobs. We want to get rid of those that are clearly not the target. So we want to discriminate based on, aspect ratio, orientation, or if it's like incredibly small and it didn't get processed out by the morphology operators. If the target that you're actually looking for is multiple blobs, like in 2019, where it was these 2 rectangular bars that I've made a mock-up here, figure out which blobs can feasibly make a target. So, for example, the top one would be a correct target in 2019, and the bottom one would have been in between the targets, which is not a real target, but possibly a match. Once you're done with all that, you want to take the information you got from the Jetson and convert it into something that the RoboRio can use. So we get the position of the center of the target relative to the camera center. We found it helpful to convert it to -1 to 1 instead of the pixels, which makes it easier to deal with resolution changes if you change out your camera or whatever. And then possibly estimate distance in the Jetson based on the area of the target. If it's a larger area, it's closer to you, or if it's a smaller area, it's farther away, or the angle of the target vertically and your robot's height, for example. You could make a mathematical model to figure that out. Then you want to use the target information. So on the RoboRio, So you want to turn the camera position, that -1 to 1, into an angle using the field of view of the camera. And then you'd want to use the distance you calculated to make a decision, like, for example, when to score, or to compensate for the camera not being at the center of of rotation for your robot, whether that's a turret or your drive base center of rotation. So then you would want to find the location of the target in space based on the angle and the distance away from the camera, and then calculate where that is relative to the center and turn to point at it. The last thing we do is we stream, like I mentioned earlier, the vision stream to the driver station so that our drivers can make sure that the vision system's working. And then we also annotate it so that, again, they can see that it's working. We put distance on there and the center of the camera frame. And then you want to, what we've implemented is a way to change the exposure dynamically so that the operators can have a look through the vision camera at the normal exposure level, but then you can darken it down to a vision exposure level so that the target isn't so blown out and you can get better tracking. All right, so that's all I had to say about that. Our code is available on our GitHub, and you can take a look at our 2019 and 2020 vision repositories.
Up next, Kevin will share some of his thoughts. Yeah.
Okay, so my name is Kevin Jaggett. Thanks everybody for coming out. I'm a mentor on Team 900. I've been on the team for about 6 years now, mainly mentoring software, but doing a little bit of everything, I think, just like most mentors. I put our support email on here in case you have questions after the presentation. This will go to me, most of the other mentors, and we can forward it to our students if you actually want the real information on how our code works. So what I wanted to do today was to give just a quick overview of what the zebracorns have been up to for the past year or so. I'm not going to go into too much detail on any particular subject, but feel free to ask questions. I'd be happy to discuss them here, or like I said, check out our email address if you want more detail and code. So kind of an outline, we've got some new hardware we're working with. We have some updates to our retroreflective tape targeting. And then we've been working with machine learning for object detection. And then I'm going to talk a little bit about how we use these results to automate our robot. So the hardware setup we're working with this year, we have a Jetson coprocessor. And this year we're using the Xavier NX, which is the latest iteration of the Jetson family. It's kind of like if you heard the Jetson Nano, it's about the same size, just a little bit faster, actually a lot faster. And like other teams, we use this to offload most of the compute-intensive operations off the RoboRio and do them on something more, I don't know, better suited for vision processing. The other big hardware update we have this year is we've moved on to using the Stereolab Z2 camera. This is an RGB plus depth camera. So it's got 2 lenses, and it uses stereo vision to calculate distance to any pixel on the screen. And this is a real benefit because it lets us convert from the image coordinates into real-world XYZ displacements that we can use to drive the robot or target a turret with it. Our retroreflective tape targeting, it's actually very similar to the process Anthony was talking about. So I think a lot of teams have kind of figured out the right way to do this. Our code is also uses OpenCV. A couple of differences I will note. The first one I mentioned here, which is since we're using an RGB plus depth camera, we get an actual range to the target, which lets us convert to, like I mentioned, actual real-world coordinates we can use to drive the robot. The other difference we use is we have kind of a different way of filtering and finding green pixels. So instead of using HSV filtering, what we do is we take the red and blue pixel values of each pixel and add those together. And then we take the green value and subtract the red plus the blue from that. And what that does is for pixels that are only green, it gives a really high value. For pixels that have no green, so basically they're not reflecting any of the LED light, it's a very low value. And then the interesting part is if we have something that's got high red, green, and blue values, for example, white light, you can see the fluorescent lights up here at the top of our target. Those would get filtered out because the red plus blue component would kind of cancel out the green. This is kind of a quick and dirty way to get like a binary image of green-only targets. Let's see. So the next thing we've been working on this year is some machine learning to do some object detection on the field. You can see the image here. It's an animated output of our code running on one of the Kickoff videos. This is one of their drone videos they flew across the field. We're able to run basically at camera speed doing this kind of detection on the field, and we're detecting 37 different type of field objects, so anywhere from the game pieces to random graphics, some tape on the field, things like that. We did this by taking about 1,500 images and labeling roughly 14,000 objects in those images. And we made our data set open source. You can see the link here to our GitHub repo. Or if you want to see more detail about this, check out our website, which is team900.org. And then in the labs subdirectory, or the labs link, will be a link to all of our white papers from this year. And so uses for vision data. I mean, getting vision running is cool, but unless you can actually use it for something, it's kind of a lost cause. So this year we're using it, I think, like a lot of teams, for automating our shooter. We have a turreted shooter with a hood. So we use the results from the retroreflective tape to figure out the angle to point the turret and then how fast to run the shooter to hit the right distance that we're at. We're also using the results from vision to localize ourselves on the field. So we take the results from either retroreflective tape or from the object detection code, and we combine that with a map of the known locations of things on the field, and then plus a history of the location of the robot. And we can use that to figure out where we are currently on the field. And you can see that demo in the lower right-hand corner here, where the image on the right with the moving squares is kind of a simulation. The big red square is the robot, and then the red, green, and blue smaller squares are vision targets we placed in the field. And the image in the left is showing the outputs of our localization code running. So as it moves around, it uses the camera data to figure out where we are in the field and give us a pretty accurate position relative to those known targets.
So now we have Lyra.
Hi, I'm Lyra, and when I was on Team 1678 in 2017, I wrote a vision program. It wasn't especially complicated, but it was very accurate and very reliable. I believe it was one of the only systems that was known to work both indoors and in sunlight. Our setup is very similar to what Anthony described. We get blobs of bright color and do some processing on them to find out which one is the target. The key to this, though, is to apply a lot of different filters. There's several different ways you could use to describe an object. You could describe color, its shape, its position, and in some of those characteristics, the target is quite similar to other objects, and you would have to strike a balance between filtering out things that are the target and not filtering out things that aren't the target. And if you filter with more different characteristics, then you don't have to do that, because you can get a more well-defined area of shapes. And because of that, it's better to write your filters that will keep the target in than ones that will reject everything that isn't the target but might reject the target as well. So we have multiple different filters. We mentioned the first one we do is we filter by color. The target has to be very bright. For us, even on the minimum camera brightness, the target was still sometimes so washed out that it was white. So keep that in mind as well. the target isn't very small. Anything very small is noise, and anything very large is probably glare off of something that is close by. And the target has to be a certain location and shape. The way that you should measure the location and shape isn't by just tuning values. Don't say that, okay, this looks vaguely rectangular. You know exactly where the target is in space. You know how high up it is. And since you know the angle to the base of the target, because you can get that from camera data, you can use that to calculate how far you are if the object is in fact a target. And the same goes the other way. You can use that information to calculate where the top of the target should be given the base of the target. And if the calculated top of the target and the actual top of the target are close to each other, then there's a good chance it's a target. But if they're completely far apart, then it isn't the target. If the target is askew, then you can also use the X position as well as the Y position in the camera. That gets a little more complicated, but it shouldn't be too much more complicated. One thing that doesn't get mentioned enough when discussing how to implement a computer vision system is what to do once you actually get that position data. There's a temptation to say, okay, we have a decent frame rate, we can use this as just another sensor, use it for feedback on our PID loops, but that doesn't work very well. There are a few differences that make a camera meaningfully different from other sensors. It has a higher noise, it has a lower sample rate, and higher latency. Those last two are a big problem because PID loop has a certain frequency, and if the noise or the lag is high enough, it can induce resonance in your PID loop. This is bad, and I ran some calculations on how much lag there would actually have to be to cause problems, and as little as 5% of the period of the PID loop starts to get a major hit in performance, and after around 8% or so, your PID loop is useless. It does nothing. So running feedback off of purely the camera data is a bad idea. What we do instead is we timestamp each image that we get from the camera, so we don't use it directly as feedback. We use other sensors like encoders or a gyroscope to actually run our feedback loops. Then once we get the timestamped image data from the coprocessor, we maintain a history of what position the robot was at, and then we look up what position the robot was at the time that this picture was taken, before all the processing, before everything was sent across the network. And then we look up what the position was at that time and use the data at that time to calculate where we should be, because the camera says we should turn this much. If we've moved since the image was taken, our answer would be incorrect, so we have to use the old value to know where we actually want to go. And then we just run a motion profile or feedback loop off of our encoder data and then take another picture afterwards to check that we're in the right place. if you want to see how we implemented this, I put a link to a GitHub that actually implements this algorithm on the screen. And if you want to email me, you can also use the email in there, although if you have questions, ask them in chat.
Yeah, so now let's open up the discussion to the audience. And if the audience has any questions, feel free to ask our panelists. Leave it in the YouTube chat section, and I'll relay those back to our panelists. All right. So in the meantime, how about you guys answer, should your team use like a pre-built solution such as a Limelight, or use a custom vision solution?
So my team has put some thought into this actually recently. In previous years, we'd had students that were very interested in implementing a custom vision solution like the ones we're describing here. And that worked out very well for us. But as time goes on, we've been getting, this year we've gotten a student that's not super interested in vision, but interested in the other aspects of programming the robot. And so we've decided to try using the Limelight in some capacity and see if it works for our needs. And if it does, then to use it, because then the student can focus their attentions on other parts of the code. But because we have the mentor support to do custom vision solutions, it often works out very nicely because we can do whatever we want with changing the exposure and whatnot.
All right, and your comments on the topic, Lyra and Kevin?
Yeah, we have kind of a similar approach where we have enough students who are interested in doing vision code that we can put the resources to it to make it work. I think for a team who is just starting out with vision, especially given how good some of the prepackaged options are now, it may make sense to start with those just to get a feel for what's even possible. Maybe use it as a learning opportunity. It's a small, well, I don't know, small is relative, but it's an investment to actually get like a Limelight in the lab to work on it. But I think just having one in your hands to play with it and see what the options are would give you an opportunity to figure out if this is something you want to really dig into and learn a lot more about, or if it's something where you just want to put it on the robot, check a few boxes, wire it up, and move on to software that actually helps win matches.
And Lyra?
I'll admit that I have not worked with a Limelight or similar system, but for us to get a vision system to the accuracy that we desired, we found it extremely helpful to implement methods that was specific to the target that we were detecting, like the characteristics of, in 2017, there were two targets, one above the other, and we looked at both of them to see, is their relative position correct, that this can actually be a target. And for us, the fact that there were two objects of very similar size in a very similar place indicated to us that a lot of pre-made systems would have trouble dealing with that.
Yeah. So you mentioned that the shape of certain targets are important in code. So can you provide some concrete examples of how you would describe those shapes?
Yes. So in 2017, the targets were two bands of retroreflective tape. So we used one band. So we took one band as the. Sorry, let me explain this again. We calculated the position of the robot based on each of the bands independently. Just saying, okay, given this angle, what's our distance from it using only this? And if the positions from those two values agreed with each other, then we said, okay, this is the target. And if they didn't, then we said, okay, this isn't the target.
All right. And so, for all the panelists, what's the importance of vision, like, to win? Like, how needed is it to become a successful team, and its influence on a winning team?
Well, I think the simplest answer is humans are bad at aiming robots. You don't have a first-person view of what you're doing, and they often require very precise distances and angles.
All right. Anything to expand on that, Kevin and Anthony?
Yeah, I'll come at it in slightly a different direction. So I think a vision system is not going to make a robot that can't aim any better. So, for example, if you have a turret and you're shooting at something, and you set it up and you line it up perfectly by hand, and you shoot 10 balls and only 3 go in, a vision system is probably not going to help you at that point. That's maybe an example of where you should focus on mechanical or something more. But at some point, you're getting to the point where you're hitting 80 or 90% of the shots, and that's when exactly a vision system will help speed things up tremendously. But I think pretty much every team has to make that decision for themselves. Are we at the point where we can just about hit 1 ball out of 5, or do we hit 5 out of 5? We just need to move quicker. I think everybody is somewhere along that continuum, and being honest with yourself is going to probably the right way to evaluate that question.
Yeah. And so, for introductory teams, how would we what's a good starting point for a vision code? Because some of the processes that were shown, you said that using limelight is a good way to get started. But what are some other concepts that teams can use to start off?
I guess
if you sorry, go ahead. Oh. All right. If you're just thinking about how to get started with figuring out how to do image processing, certainly just getting the thresholding and the filtering working so that you can just see the target itself, and then for example, OpenCV has a convex hull function, so you can get you can fill in a contour of the target. So it's just this big convex blob, so there's no interior spaces, and you can just find the center of it. And so if you're just getting started and just trying to figure out what you can do vision processing wise, you could just find the center of the target and report it. That's like the basic thing. Then once you do that, you can start trying to calculate distances and do control loops with it. But if you're just getting started, just finding the target is a very good starting.
And
the
so,
other thing, if I can throw something in real quick, which is I think all of us kind of explain basically the same process for retroreflective tape targeting, with some minor variations between teams. But I think a new team starting out could really benefit by learning from what other people did, either by looking at code or looking at white papers, which I'll toss out there because we have several that are available. But I don't think reinventing the wheel at this point for retroreflective tape targeting is really going to be a benefit. There's a lot of things out there you can learn from other teams and not have to take the 3 or 4 seasons to make all the mistakes that they did to learn from them.
So one of those differences in your guys' processes was that Kevin and Anthony, you guys both used dilate and erode transforms, but Lyra didn't. So what was your thoughts behind choosing those transformations?
I'm sorry, could you repeat what kind of transforms?
Dilate and erode transforms.
Oh, the morphological operators?
Yeah.
Yeah, so I mentioned it on my slides, but I didn't say it during the presentation. If you want to get rid of little speckly noise, one way to do it is to blur the image, and then it sort of evens everything out. And because the targets are large, flat planes of color, you can still see them even though it's all blurred. The problem with blur kernels is that they're slow. They have to operate on many, many pixels across the entire image, and so it's difficult to get them to run in real time. So the advantage of morphological operators is that once you have it thresholded, morphological operators are extremely fast by comparison, and so you can get rid of this tiny little speckly noise stuff that happens to be green enough and bright enough to match your threshold, and you can get rid of it with these morphological operators. It's also very simple to sort of understand how it works. If you get into the details of exactly how it functions, it's pretty simple. So,
And then Kevin and Lyra, your thoughts?
Well, the way we also had to deal with the small specks of color as well. And the way we dealt with that was just going through the list, and anything with a very small bounding box just pulled out of the list and got rid of. And the reason we did that instead of the morphological transformers is that our LED was so bright that even on the minimum brightness, it was white. So our threshold had to go all the way to pure white, which means our noise specs were larger. There weren't very many of them, but they were large enough that a dilate and a road to get rid of those would also get rid of the target if it was far enough away.
All right. Kevin?
Yeah, so we have that in there from past years. I think it's probably a really good point that, especially this year where a lot of teams are shooting from a fairly long distance, that it's possible to unfortunately dilate and erode away part of the actual target if it's a really, especially with an angled target, I could see that happening. So I'll say that our code still does have that in there, but I'm probably going to take it to go back and try it out and disable it and see if that helps us detect things better at long distances.
And so, what are some cameras that your teams use for their vision systems? Like some recommendations to get started, like what cameras would you consider buying?
I mean, USB webcams are a cheap, easy way to start. They just work. You plug them in and they function. My team uses essentially USB webcam, except that it does have, it's PCB mounted. It's not like a piece of consumer electronics. And that allows us to have interchangeable lenses, which I briefly mentioned. You can have different lenses for different distances. So, for example, in 2019, where we had a turret and we were looking to the side a lot so we could turn around and engage the target, we had a very wide angle lens. But for this year, we're shooting from a very long distance, and so we've changed out for a different focal length that lets us see the target better but have a smaller field of view.
All right. And then Kevin and Lyra?
Yeah, I'll agree that there are a ton of webcams out there that are just plug and play, and if you're just starting out, that's probably a relatively low, it's a low cost, easy way to get started. I don't know. I wouldn't necessarily recommend the camera we use as a first attempt, but if you find that you want to try something a little bit more unusual, we've been happy with the Stereo Labs products. They're really, it is really nice to be able to get a distance to every pixel on the field that you can see. It makes the calculations a lot easier. You don't have to guess what the height might be or, and back out the distance. You just get the value as a pixel value. So that's really helpful. And then if you decide to go with something like a Limelight, your choice is kind of made for you. You get a camera with that. So that would be another decision you could make.
We used a USB webcam as well. I don't know exactly what model it was. I don't remember, but I don't think it was a super high-end product. You don't need HD streams to get good data from these. A cheap solution works well.
So we had some.
If I can jump in there, yeah, I think the highest resolution we've ever run on the field is, we call it 360p. It's basically like a widescreen VGA. So you really don't need incredible resolution to be doing the kind of processing we're talking about here. You don't need like a 1080p or 4K camera to have an effective vision system.
Yeah. So building on that, there's an audience question asking, what kind of characteristics do you look for in the cameras that you use?
It's important usually for these cameras to be able to adjust the exposure, because like Lyra was saying, targets can get washed out where they look white, even though they're very bright green. And so lowering exposure almost to basically for every camera we've used, we lower it to the lowest possible setting. And some cameras are kind of stingy about allowing you to do that. So you might have to find a couple, or try a couple before you find one that lets you. Yeah, I literally just exposure settings and then possibly some color funny business when you, especially when you get to low exposures. We've sometimes had a little bit of a problem, but generally it's okay.
To piggyback onto that, if a setting says that you can change brightness, that typically isn't the same thing as exposure. It just takes everything down a notch after the picture is taken, and you lose that data.
Then Kevin, do you have any characteristics that you'd look for in a camera?
I think I hit everything that we would look for. The exposure is really probably the biggest thing you would care about. If you can get higher frame rates, sometimes that would be nice. So a lot of standard webcams run at 30 frames a second. If you can run it faster and your system can handle that, that might be a useful feature to have. But it's way lower in priority than being able to get the exposure right, because if you can't get that, you're not going to see anything at all useful on the field.
Mm-hmm. So Kevin and Anthony, you guys mentioned using Jetsons. So there's a question asking, for teams that don't use the Limelight and are using Jetsons, how do you harden them to become more reliable on an FRC robot?
I can answer this. So my team, I mentioned we use an Orbity carrier board, which the one that the Jetson TX1 comes with, the carrier board that holds the processor and everything, is like this big. Let's see if I can get my fingers in frame. It's huge, but it's flat, and so we bought the Orbity carrier, which makes it more like a box instead of a big flat plate, which helps it to take up less space to minimize footprint. But we also 3D printed a case for it. So if you have a 3D printer available, I would definitely recommend doing so, because it protects electronics from metal chips and other random crap. As far as power is concerned, let's see, the Jetson takes 12 volts. No, it doesn't. It takes it from a range of voltages, actually. That I believe it has a power supply on it, but I might be wrong about that. But regulated power is available from the VRM, and if it works with the Jetson, I would recommend using it.
Okay. Yeah, we do a lot of the same things. We used the TX2 last year, which is basically the same form as the TX1. The giant, 8-inch by 8-inch PCB that doesn't fit anywhere. So we used a slightly different carrier board. For us, it was an Avidia J120, which is basically the same size as the Jetson heatsink module. It just makes it a little bit deeper. So the same thing Anthony was talking about. A case we found was very important. Aside from metal shavings, which are an issue, it also keeps things like game pieces from hitting your USB connections. As much as you can put inside the case and just have wires coming out, so even not having connectors exposed is nice. For the power supply, we actually ran a buck boost converter to do DC to DC conversion. It did a really good job of smoothing the power out, and then we could run it off a regular PDP slot that way. So we had problems where if the robot drove too hard or we turned the LEDs on and off, we could reset the Jetson. Adding the buck boost converter fixed that problem pretty much completely.
I forgot to mention, actually, and it sort of falls into this category. You have to set up your Jetson so that when the thing turns on, it launches your vision application. We never mentioned it, but that's very important to have a script that auto restarts in case of a program crash or whatever, because some random stuff will happen on the robot, or your power will fail, or something weird will happen, and then the Jetson turns off and it turns back on, and you have no vision. I just thought I'd mention that as a minor note.
Yeah. And so another audience question. As panelists, what are your thoughts on using software like Grip, Photon Vision, or Chameleon Vision?
Okay, so I saw this audience question and I Googled those three things because I'd never heard of them. All right, so as far as I can tell, Grip is like a GUI-based application that generates some OpenCV code. So, I mean, I'm all for having this program that sort of shows you what's going to happen before you implement it. This seems like a great way to sort of feel your way around it first. And then when you're done, presumably you can export this to some code that you can run on the Jetson. Like I said, I've literally never heard of this before now, but it looks fantastic. You can figure out if your pipeline works before you have to put it on the Jetson and try to get it through the robot. So Photon Vision appears to use Solve PNP, which I have heard of before. So Solve PNP is a thing that OpenCV has a function to do. Solve PNP tries to figure out the robot's pose, which is the orientation and location, based on a target that it knows the size and shape of, and so it's super powerful. We tried to do it recently, and what we found was that without much higher resolution than what we have, we had a lot of trouble with finicky results. So, for example, Kevin was saying that he's using 360p, right? And we use, I think, 480 or something like that. But if you want to do Solve PNP, you got to go higher. But it's definitely like super cool because you just look at the target and you know where you are. It's like the best of all worlds. So, but again, I don't really know much more about it than that. So I mean, these softwares all look great. They look like they help you in programming up your vision stuff. Looks good. To answer the question.
And then another audience question: is there a reason to use network tables, or are there other alternatives to transferring information from a vision system to a robot?
Let's see, we've experimented with using network tables in the past. We didn't settle on using it just because there were other options that made more sense for us. From what I understand, that network tables will build for pretty much any coprocessor that you want to run it on. So it'll work on the Jetson, it'll work on a Raspberry Pi. That would probably be the lowest barrier to entry for people. It's something that's familiar and useful and works for them. In the past, we've used something called ZeroMQ, which is a really lightweight networking application that lets us transfer data over. And I think Anthony mentioned it, but we're doing something very similar where we're transferring the minimum amount of data from the Jetson we need to. So instead of transferring the whole image over, we're really just giving targeting information. Like, here's a target, here's the coordinates of it. So it's a very small amount of data. If you're transferring whole images, then I think the idea of using something like GStreamer or some of the things provided with the WPI lib would be useful there. We're more familiar with GStreamer just because we use it, but I know that, well, at least I've seen references to WPI lib adding stuff to their Raspberry Pi image to make this a fairly straightforward process also.
We used UDP messages. We bundled up vision data in a protobuf structure and serialized that to send across the network. But it doesn't even need to be that fancy. If you're just sending angle and position and then a Boolean whether it's found, you can just send a handful of bytes. All you need is the known format.
Yeah, Code Orange also just used UDP sockets. We sent a number of angle and distance chunks, one for each target we found in 2019, which sometimes you could see more than one. And then on the RoboRio, we'd select one based on distance and some other criteria. And then, like Kevin said, we used GStreamer to encode it. So that makes it a lot easier to send within the bandwidth limit because, when you're doing vision, most of the frame is black. And so the H.265 encoder can really crunch it down to basically nothing, and so you can skate in under the bandwidth limit.
Isn't the bandwidth limit just for the Wi-Fi? If you send something just from a coprocessor to the RoboRio without it going across the Wi-Fi, does that go towards your bandwidth limit at all?
I don't think so. No, I was talking about streaming to the driver station specifically.
Oh,
if you want to
okay.
just store it on the RoboRio,
you.
yeah, no, that's no problem.
Okay.
And then another question is, how did, as panelists, how did you solve the issues of having bright green lights and keeping robot inspectors happy? I know, like, the light might personally hurt my eyes.
Yeah, so on Code Orange, our bright green LEDs, like I said, we use a what the heck did I write? Exactly. We use a constant current driver we bought from Adafruit, I believe, and it has a pin to enable and disable it. So it was super cheap. It was like $10 or something, and you can just hook up the enable disable pin to the RoboRio and use a digital input output. I forget exactly how we implemented it, but if you do it with a relay versus a DIO, you can get it to turn off when the robot boots immediately, which is nice so that you don't blind people when you turn it on. But other than that, yeah, just hook it up to the RoboRio and you can enable disable it. That's the easiest way I can think of to do that.
We also had a switch on it so we could turn it on for the field and off for moving it around and inspections. So again, we wouldn't blind people.
Okay, yeah, the zebra corns are a little bit unusual, so we basically just threw a cloth over it when it was in the pits, so it wouldn't blind people. But more seriously, we printed up a 3D printed case for the camera that has a recessed place for the LEDs to go in, and we can recess them a little further back so it still points at the target but doesn't blind people off to the sides, so that does help a little bit. And then we also had an implementation of hooking up to a GPIO, or I guess a DIO in this case, being able to shut it off as we needed to.
Yeah, we got a little fancy and had it only turn on when we were actually tracking the target, which was nice. But yeah, you can be a lot simpler than that.
Yeah. And so, what's a good language to write your vision code in? I know it varies depending on the team. So, panelists' thoughts on that?
We used C++. I believe a lot of languages work with OpenCV, but most bindings are written in C, so C and C++ are just easily compatible with everything.
I mean, there's something to be said for language compatibility. So you might want to, if you're writing your robot code in Java, you'd want to write your, or even just programming knowledge. If you're writing your robot code in Java, then it might be nice to write it in Java, your vision code in Java. However, C++ has a definite performance advantage over Java. So if you're running into performance issues, that is a way to improve it, is to switch to C++. We've had programmers, luckily, that are experienced in C++ or have been able to learn it in a fairly short period of time, so that wasn't a big deal. Java and C++ are both object-oriented, so there are definite differences, but they're not wholly dissimilar. So, yeah. We wrote ours in C++, just for reference.
Yeah, most of our code is in C++. We do have some in Python, which is also another binding that supports OpenCV. And for us, we use it because it's also useful for TensorFlow, which lets us do some AI stuff. The big advantage we found from Python is rapid prototyping is really rapid. So a lot of the vision stuff, you'll get something together, get a pipeline idea in your head, and it's really nice to be able to quickly test it and see if it works or not. And then Python is a good prototyping language for that because it's really quick. You don't have to compile. You're not debugging out-of-memory pointer errors like you could in C++. But that being said, the majority of our code is in C++.
Mm-hmm. And so, on your guys' respective teams, what do you guys look for inspiration with your vision systems? Like other teams or other groups or things when you're, fixing and producing these vision systems?
Yeah, I know for us, one of the things that was really helpful early on was 254 put together a talk at Champs that laid out a lot of some of the more detailed things that we'd seen and we knew kind of how to fix, but not really why fixing them helped. So things like why does the target turn like this kind of blue-green teal color if your exposure is wrong? They were able to explain that in a lot of detail that made a lot of sense. So looking at that presentation helped. And then just seeing what other teams are capable of, watching what happens on Champs or, even, regional championship matches, seeing what we can get inspired by from there. Maybe we want to try and make a robot do that or, ooh, we're close. We could almost do that. Let's make it work. That's really nice to see.
I mean, 971 is always fun to watch because they have some very good control going on. But 254 has done some impressive stuff. Let's see, which year was it? It was 2016 that they had their vision system was running off an Android phone, and they had tracked the goal so well that they were strafing left to right and were able to point at it basically constantly, and it was very impressive to see. Just like Kevin said, just see what other people are doing, see if they do some cool or interesting stuff. I learned some stuff from listening to your guys' talks about it, doing the machine learning and stuff. So yeah.
For us, we looked at talks and published code from 971 and 254, but our biggest source of documentation was just the OpenCV tutorials themselves. I think they're very well written and easy to understand.
So we have time for 2 more questions. So if the audience has any more questions, please put them in the chat right now. And we should be wrapping up very soon. If you guys have more questions afterwards, the panelists' contact information should be on the Capital City Classic website, and these videos will be put on YouTube, so you can watch it later and for the contact information through there as well. Well, in the meantime, how about we answer this question? Do you need a coprocessor, or can you simply run vision code through the Robo Rio?
I mean, you can run stuff on the Robo Rio. I've seen some projects that do that. The only one that I believe I saw that was working at a decent amount of, or working at a decent efficiency so that you can get a high enough frame rate was something that was using some assembly stuff. The Robo Rio doesn't have a whole lot of processing power, and the Jetson has a graphics card in it. It is made to do parallel processing, so it's super fast at doing these things. OpenCV has connections for NVIDIA CUDA stuff. It can access the graphics card at a very intricate level. The Robo Rio is a processor like a regular CPU. It can do the vision processing. It's just a lot slower. So yes, and also Code Orange actually, when we first started doing vision, was running vision processing on our driver laptop. So we would send the frames over Wi-Fi and then process them on the driver laptop and then send that information back to the Robo Rio. That introduced a huge amount of lag, which we had to deal with in the control loop. But it ended up working out. So if you really can't deal with the coprocessor and your laptop is somewhat powerful, you can try to do that. But I really wouldn't recommend using the RoboRio because it's got a lot of other stuff to do and can't really handle the vision computations.
If you do vision on the RoboRio, I mean, I mentioned how to deal with latency, but you also have to worry about bleeding performance away from more important tasks if you're doing that on the RoboRio. In 2014, there were goals, and one of them would be highlighted for extra points, and this would be before the match. So to score that autonomously, what we did was we did just use the driver station to run vision, but that was because we only needed one picture to process.
Yeah. One thing I'll mention, from what I feel bad saying this because I haven't actually used one, but my understanding is the Limelight is essentially a coprocessor and a camera combined into one that you can just kind of buy off the shelf. So that kind of gets you the benefit of having a coprocessor where you're not taxing the Rio or having to really run it, beat it up to make it work. But at the same time, you don't have all the downsides of getting a coprocessor working, like we talked about the power supply and how do you transfer data back and forth. All that's handled for you. So again, that's kind of pointing towards, as a team who wants to know if they should use a coprocessor or not, maybe a Limelight or something similar as a way to start, like kind of an in-between step there and see if it's what they really want to do.
A big thank you to our panelists. Thank you for coming to this workshop. I believe we have another workshop after this, or yeah, CCC should have another workshop after this. But thank you to our panelists. Big thank you there.
Yeah, thanks for having us.
Yeah.
Hello, everyone, and welcome to the Virtual Collaboration for Programming. I'm the moderator, Kevin, and let's go and have the panelists introduce themselves.
Hi, everyone. I'm Mohammed Al-Mashad. I am the current software robot lead on Citrus Circuits. I'm going into my 5th year of FRC with 1678, and I was the Citrus Service Programmer in 2020.
Hello, everyone. My name is Apoorv Mishra. I'm a 4th-year veteran member of 1678. I was also a secondary Citrus Service Programmer in 2020, and I had led new programmer training this offseason.
Hi, y'all. The 2021 season is going to be my 3rd season at FRC. I'm the current software director for Team 254, the Cheesy Poofs. Outside of robotics, I like doing math, physics. I also play some League. So.
Hello, like I said earlier, I'm Kevin Rockwell. I'm the moderator. This is going to be my 2nd season on 1678. I'm back-end leadership on software scouting, and outside of robotics, I do a lot of D&D, cross-country when we aren't in the middle of a pandemic, and general programming projects. So going into the general outline of the panel, we have it kind of split up into 4 general topics. So first we're going to talk about team bonding, then we're going to talk about sub-team collaboration and logistics, so that's a little bit more general organizational matters. Then we're going to go talk about code practices and other stuff just related not quite to the organizational matters, but more specifically to how each team goes about writing the code. And then finally, we'll discuss things that we found that are mainly specific to meeting online and over the web. But all of these the things we discuss should be applicable to virtual collaboration. So let's go into team bonding. So just starting off, how do the panelists, how have you guys done team bonding with your teams?
So on Citrus Circuits, we've had team bonding inside our sub-team and then outside our sub-team. I'll start off with inside our sub-team. So the first thing that we did 2 sessions of team bonding when COVID first happened with all the veterans. And then I think about 2 months ago, we had a bunch of new members join us. We did a 2nd session of team bonding. In each of those sessions, we had different activities just to get to know each other. We had different icebreakers. In the 2nd session of the veteran training, I think we played Jackbox games. So just like getting everyone to like break the ice, getting everyone comfortable with each other, that's the main thing that we tried to do on sub-team bonding. I think Apoorv can take on team bonding and smaller groups of that.
Yeah, I mean, just like Mohammed said, right? We did a lot of small activities, especially when our new programmers came on, to get everybody familiar, right? I think something really important for collaboration and programming in general is getting comfortable with the other programmers, right? Being able to ask questions, asking for help, getting to know everybody, so you can just communicate better overall. And so that was like a huge focus of ours when we, first were introduced to a lot of the new programmers that we took on this year. Especially being in a virtual environment, it becomes more important to have such team bonding, right? Just to, make the situation a bit more light, get everybody comfortable with each other. And overall, I think, that's really important also just before going into training and everything, right? Because if you're doing new programmer training, you want to make sure that your new programmers are willing to ask for questions even outside of a meeting session, so they can get the help they need. So having something like team bonding to kind of like pave the way for all the other interactions to happen on the sub team become really important.
Alex, how does 254 go about doing that, both on a sub team level and a team wide level?
Yeah, so we didn't really do any team bonding like after this season kind of abruptly ended last or in spring, I guess. But like for fall, we've had a lot of team bonding activities, I guess, with the new members. So what we do is we basically split into like kind of like breakout rooms, maybe like 10 people in a room, with both new members and for veterans. And with like each breakout group just decides on what they want to do, like play maybe like Scribble or like play Among Us or something, some game or something. Yeah, so it's pretty great for getting to know like new members and like veterans. Pretty good for getting new members integrated. We've also done some team workshops where we like again we split into rooms. So that's pretty cool. It encourages collaboration. We haven't really done much for sub-team team bonding, but yeah, that's what we've done for like whole team bonding.
How effective do you guys think that team bonding is as a way of building collaboration? And especially if you didn't used to do it, have you noticed any gains in doing it this year? Or does it mainly just counteract the challenges put in place by having to work remotely?
So, kind of reaching out of, just the sub team itself for a moment. Something that, like 1678 as a team did this year was we had like team bonding groups that, connected people from different sub teams together, right? So that they could meet virtually. And, like something like that becomes really important because especially in these times, interaction with other people is a lot more minimal, right? We have social distancing, we have quarantine, etc. And so having that sort of opportunity to get to know others better, right? And get to know them, especially outside of, just a work setting, right? In which there might be, some stress or, different things to worry about. It becomes really important and frankly enjoyable, right? To be able to just, have a fun activity like that over which you guys can get to know each other better. So I think overall team bonding can be really effective for just becoming more comfortable with the team members you have to work with, because in the end collaboration is how we're going to get things done. And so making sure you can have that step one to get everybody on terms with each other is a pretty, I would say, effective thing for our team as a whole and our sub team.
For
does
us,
anyone else have any?
oh yeah. Okay. Well, yeah. Okay. I guess I'll just kind of talk about it. So on our team, I don't think team bonding is or virtual team bonding, I guess, is that effective. It's definitely effective to some degree, right? Because it is good to familiarize yourself with new members, to integrate new members into your team. But I feel like the virtual aspect kind of degrades from the effectiveness or detracts from its effectiveness. We used to do like a lot of members used it to like in our lab before builds and before meetings and that kind of stuff. So I feel like that was more effective, where we were just talking about random stuff compared to like this team bonding stuff, because a lot of the time we're just playing games, not really getting to know each other. So that's just my 2 cents on how we do it. But yeah.
Kind of going off of that, I definitely get the sense that it does seem a little bit more forced trying to do that sort of thing remotely than it does other ways. Have any of you encountered ways to make it seem a little more natural and less just like we're going to go and try and push people together to make them talk?
I remember a few weeks ago, we had a team meeting, and I think one of the new members asked a question. The question was just like talking about like how difficult it is for them to like learn Java. They were learning Java at the time, and then everyone just pitched in like, "Oh yeah, hey, like when you started as well, like it was really hard." And then like the meeting kind of like didn't go as it was really planned. There was supposed to be like a lesson that day, but there wasn't. And then we just had like a whole discussion about like imposter syndrome and like how hard it's to like get started into programming. So that was like honestly like a really natural team bonding event that happened. It wasn't really planned out, but I see that as one of the peak team bonding events that happened over the COVID season. As for like everything else that's like kind of like forced, it's kind of hard to make it seem natural, especially since like you don't really know anyone in your group. Unless you're a veteran with another veteran, you usually don't know who else is in your group. So yeah, like it does seem kind of forced, but like the scenario I described earlier, that seemed like natural. It was natural, and I think that was probably the most effective team bonding that happened on Software Robots.
Yeah, I mean, I think like just to answer the question like directly as well, right? Building off of what Mohammed said, I just think that relatability and like stressing relatability between members is really important for making things seem more natural. In the end, the way Mohammed described, right? In that situation, we had all gone through a similar issue with having difficulty understanding code and getting started with writing code when we first started on our sub team, right? And that's a situation that lots of people can relate to. So, just finding those common places, right, in discussion and just talking naturally about it, I think becomes really important, right? Because, the more you can relate to somebody, the more you realize, you guys are similar, or you guys can at least understand each other's perspectives, and then get closer to them in reality by understanding them a bit better. So, I guess that sort of discussion reaches beyond, like doing a simple game of Among Us or, some other activity, and can be really helpful for team bonding.
Does anyone else have any other thoughts on team bonding, or should we go on to the next topic? Alrighty.
I say we can.
Right, so the next topic is sub-team collaboration and logistics. So we do have a poll associated with this, so if people in the chat would like to open that up, in a couple minutes we're going to put up the poll question as we get to the topic of discussion. So let's just start off with some pretty basic questions. So how many people are on the sub-teams for both 1678 and 254?
As of right now, I think we have 12 members on Software Robots.
Yeah, this year we had a lot more freshmen than usual, so we have maybe 12 to 14 total members on software, but in previous years we've had like 6 or 7 usually.
Is the current number about normal, Mohammed or Rapor?
On Sister Circuits, that number is, pretty normal.
Okay.
Yeah, usually it's around 12 members around this time of year.
And do you expect it to go down as we get later in the season, especially going into build, or does it normally stay about the same?
Going into build, I think we lose maybe 1 member, maybe 2. But it's pretty rare to like lose members as you go on, especially like in November. Like all the members you lose are generally like early on, like September, maybe October. So I think the numbers probably gonna stay the same until the end of the year.
Alex?
Yeah, so obviously like this year we've had, or maybe not obviously, but this year we've had a lot more freshmen join. And I guess since we have such a larger number, I anticipate that it'll go down because what usually happens is a lot of freshmen will join to see if they can kind of like balance robotics and sports or speech or whatever else that they're doing. And as the year progresses, usually more and more people will drop, right? Will say they'll figure out that they don't have time to do all this stuff and schoolwork. But I think that the virtual environment, or like the online nature of most extracurriculars, I guess, I think that allows for a lot more time, because especially in robotics, we're spending a lot less time in the lab because we're just doing workshops and stuff, and that usually takes less time. So I think that once we get to the point where we're going back to the lab, I think a lot more people are going to drop. But I hope they all stay. It's good to have a lot of people.
Yeah, so going off of having more people, how do you manage distributing work and distributing various tasks among larger groups of people, especially when some people have less experience than others?
So something that like 1678 as a whole follows, and our software sub team also follows, is something called the peer-to-peer model, where we basically have veteran members and new members kind of like pair up with each other and partner up and work together to solve through problems or to learn new concepts, etc. And I think that by using that model, or in general encouraging collaboration in that way, right, is really helpful for making sure that everybody gets something to do and that everybody has a legitimate task that they can work on, right? It's really beneficial to both parties, right, both the veteran member and a new programmer, because a new member gets to learn code, right, by seeing examples and working through it on their own with some guidance of somebody who might have more experience on the topic. And at the same time, as a veteran member, you get a lot more experience with skills such as like teaching, right? And through teaching, you obviously learn a lot more as well. And so using that to kind of pair up students, right, and work together in that way to work through difficult concepts can be really important. I know that as we go into our competition season, we use this model a lot when we get started with our subsystem code, because that's code that we want to make sure we have multiple like hands-on to make sure that we're not missing a certain part, right, and that we're incorporating the best like aspects we can into that subsystem. But having a veteran member and a new member paired up to kind of collaborate to do that work can be really effective, because both people learn while they're writing code, and you have like strong task delegation in that way, and you can know that your subsystem is going to be finished on time.
Alex, how does 254 manage delegating, especially with the sudden jump in the amount of newer members?
Yeah, I don't think I can talk too much about like our 2020 robot and that kind of stuff, but I can kind of give a timeline of what happens basically. So usually in fall, right, we have a bunch of new members join. They usually go through workshops all throughout like the fall semester or fall, winter, or whatever. And so when build season comes, usually like these newer members, they'll be working on I guess less advanced or less complex mechanisms and stuff. So they'll be working on vision and stuff. So these will usually be smaller teams. These projects will be worked on by like smaller teams of like a couple freshmen or a couple newer members, and then usually more experienced members like veterans. They'll be working on like more complex like state machines, subsystem architecture, that kind of stuff. But they will be available to help. And then after build season ends in summer, Team 254 at least is fortunate enough to be able to work on a summer project, or we have been fortunate enough to work on a summer project for the last couple seasons or the last couple of years. So usually around that time is the time that a lot of freshmen can take bigger roles in writing more software, more complex stuff, and just playing around with like autonomous and those kinds of things. And then once they're sophomores and they get to the next build season, they'll be able to take on bigger roles.
Okay, yeah. So now we're going to go into the first poll question, and question also this is directed for the presenters. So what language do you use? And for the presenters, can you give us some insight into the reasoning why you use it?
I can start. So we use Java on 254, and I guess we've been using Java for a while, but one of the bigger reasons we're still using Java is because it's the same language that like APCS is taught in AP Computer Science. So a lot of students who want to join the team, want to join the software, they'll likely have some APCS experience. Or when they go on to their like sophomore, junior years, they'll take APCS and they'll get even more like insight into how the language operates. So it's with C course. So it's or C++ course. So it's pretty nice to be able to kind of integrate, or to be able to use like classes taught in school to kind of help our sub team members develop.
In 1678, we use Java. I think we've been using it for a year and a half now. We transferred to Java because we wanted our team to be more sustainable. C++ was really hard to teach, and a lot of people didn't really understand it fully. So when we transitioned to Java, more people were able to understand like how the code worked. It's also like you don't have to like deal with memory at all, which is pretty nice, which takes a lot of the complexity that C++ had. So the transition to Java was something that our team underwent for the 2020 season, which started in the 2019 off season.
Okay, cool. So we're now going to we're going to leave the poll up for a little bit longer, just so more people can get in. But we're going to pivot the discussion over to working with version control and how the teams do version control. So, yeah. So first off, what version control software do you use, and how do you use it to collaborate?
On Citrus Circuits, we use GitHub. We don't use it just on the software robot team. We also use it on software scouting. On software robot, we use Git and GitHub. So how our code is managed is we have one master repo. That's the only repo that people pull from if they want the most recent code. And then if anything gets merged into master, it has to go through a pull request process. That pull request process requires at least two veteran reviews and approval from the sub-team lead to merge into the code base. We use PRs mainly because it lets everyone on the team like see what's happening in the code. Any changes that happen are reviewed by almost every member of the sub-team. Usually people don't have tasks to do at sub portions of build season, so they can just review pull requests. It also helps keep our code uniform. So we have a salad guide that we follow. If the salad guide is broken in the pull request and the original person who wrote it didn't notice it, someone else can be like, "Oh yeah, hey, you name a constant by putting a k before the variable name," stuff like that. In addition to the two veteran PR approvals, you also need to pass a build kite. We use a continuous integration in our GitHub. If it fails the build kite for any reason, it cannot get merged unless it's forced merged by the sub-team lead. This basically lets us make sure that the code that's getting merged into the master branch is always running and always compiling. This saves us headaches in the future. Like if someone merged code that doesn't work, it'll just break the code base for everyone else because everyone's pulling from master constantly. I think that's everything that has to do with source control on Citrus Circuits.
Alex, I think 254 uses a different method than the than the fork PR system that GitHub we use. So, can you walk us through how you do it and what the review process is like?
Yeah. So we basically just have like a master repository. Oh, we use GitHub, and then we'll have like a master GitHub repository. Or we'll have like one repository for each season's code, and then we'll have different branches, I guess, for different projects. So all the work is done on these different projects in like the official like the season repo. When we're merging branches, we sometimes use PRs. More frequently, we'll just copy paste code. That's pretty nice, especially because we've had like smaller software sub teams in the past. So it's pretty easy to keep everyone like updated on what's going on, and it's faster. But if we do use pull requests, they usually have to be reviewed by like a senior software person or like a mentor. So. Kevin, I think you're muted.
I know how this works. Yeah, so I think that's it for the collaboration and logistics. So now we're going to get into the bulkier parts of the presentation. I think we're starting off with code practices. Essentially, this is going to be talking more about how you go about the process of writing code, tests, and documentation. So we're going to start it off with a question from the chat, actually, which is, how would you recommend a team get started using test-driven development? So I think we should actually start by asking, does either team use test-driven development?
Citrus Circuits uses test-driven development. We don't use it on everything, but we use it for anything complicated, like a state machine or autos. We have some auto tests that we use that come. Also, we use JUnit. So we write JUnit tests for Java.
Yeah, we're pretty similar. We have unit tests and such as well.
Alrighty. So if your team looking into using more tests, how would you recommend doing that? Should they just start by focusing on improving test coverage, or should they maybe start by just doing tests for all the new code and then any changes they make?
I guess if you're starting with like already written code, you should probably write tests, especially for all the stuff that has like a lot of math in it. Yeah, I guess if you're starting like from the ground up, you should probably just write tests as you go for more complicated pieces of software.
Yeah, and how do you handle like when you need to unit test stuff? Do you test everything? Do you drop tests if you're running out of time and just need to get something done? What's the processes like for tests?
On Citrus Circuits, tests are generally written. We try to, so during build season, we try to have it at the start, but due to like the time shortage, it usually ends up getting done like after our first regional when people don't really have much to do. We try our best to like have it be done, as we go, but that doesn't always happen because of time, how much time it takes to write a test, make sure it's written well. In terms of what actually like gets a test written for it, subsystem code generally doesn't, since subsystem code doesn't have that much of complicated logic. State machines might have tests for them, or anything with complicated math, as Alex mentioned before.
Yeah, so we usually have tests written for more complicated stuff before it's merged into like master. The code is like put into master. So that's usually done before like the final code is put in master, I guess.
Okay. And how do you go about integrating code into what you already have? So if you're adding a new mechanism, for example, how do you go about testing that it's being added correctly and that it's not going to break anything?
Generally, before people make a pull request, they have to do a bring up. Bring ups are done with a veteran. There has to be a veteran there. More oftentimes than not, it's very rare that the subteam lead won't be there, but the subteam lead will be at every bring up. Sometimes it's not always possible. The bring up process is really important. You got to make sure you test as many cases as you can. You got to do just some number of tests to make sure it runs properly. For example, if you have a wrist, you want to go the full degrees of rotation, maybe like 50 times to make sure it doesn't break. Make sure like your code doesn't like break itself. You try to test with low battery voltage. You try to test sensors. Make sure like, oh yeah, what happens in this case? Does my code cover every single case possible that the robot would encounter in an actual match? And then once that's done, it gets put in a pull request and then usually merged. This is pretty good because you've already tested most of everything, and then if any other changes that need to get made are usually found during driver practice or during just later on in the season during actual matches or something. And those little changes can be done like really fast and really easily. Yeah, that's basically it for bring up.
Yeah, we do pretty similar stuff for bring up. The important thing is to just run like your code, test a lot of different test cases, I guess. We'll usually like require there to be a mentor, like supervising, both for like safety and to like help if something goes wrong. So, yeah.
Okay. Going into general code practices, we've already discussed language, and how do you handle keeping a consistent style guide throughout the code base?
So I mean, I think like a large part of maintaining consistency comes through like our peer reviews and pull requests before code is merged, right? Something that we really stress on 1678 is making sure that all the code is uniform, because that increases readability. It makes it a lot easier to refer back to code, etc. And so usually, if there's any inconsistencies within, the style that we use, the code styling that we use, then that will be commented within a pull request, right? We require both, as Mohammed mentioned, new members and veteran members, as many as we can, to review those PRs. So we usually catch, code styling, but I think throughout the team, because it's stressed so much, it becomes like an easy practice as well, right? Which way to style, your member variables versus certain methods, etc. Your constants. So yeah, I mean, I think overall it's really important to have that code styling in there, because it makes your code a lot more readable, especially in a case where you have a lot of difficult or more complicated logic going on, right? Being able to assess an error, right, or understand exactly where each variable within your code is, right? Going back to the idea of tracing code in general to catch errors. And yeah, I think overall, because of that, code styling gets really important. And so by reviewing that a lot in PRs, you can manage to make sure your code is uniform that way. Well,
Yeah, when we're pretty good about like stylizing constants and member variables correctly, because those are pretty easy, right? You just add a K or an M. But for I guess other stuff, like local variables within like loops, within methods, all those kinds of things, we're not too good about that. Like our code's readable, but not everything is like stylized the same way. So we're working on that. But I think it's more important to have your code be readable first, and then maybe you can focus on like make a more narrow like style guide to kind of further sync everything, I guess.
How do you ensure that readability then? Is that something done in the review process? Do you just kind of trust everyone to get it right? How does that, the readability come through?
Yeah, that's usually done during like when we're merging branches to master or something. We'll usually do like a review then. Those kinds of reviews, we have to make sure that like all the logic is sound. Every line of code, I guess, has a purpose. Like everything's readable and understandable. That's pretty helpful, because when you have someone like from outside who hasn't really been working on your code, looking at your code and seeing if it like makes sense, I guess that's like the biggest indicator of readability, right? Whether someone completely new can look at your code and understand what's going on. So yeah, but for smaller stuff, we'll have like some people will just make smaller like cleanup commits, cleanup changes. But that's all the big stuff usually is caught in review.
yeah, I mean, I think like that kind of lends to the whole idea of code documentation, right? That's something that our sub team is, beginning to do a lot more, because it's a really important part, right? It helps new programmers especially understand the way code is written, right? It helps everybody understand the logic and different functionalities of the code that you're actually merging in, right? And so a lot of the time we make sure that documentation is added where it's necessary, through somebody asking questions about different parts of the code, right? Like if you're confused about a certain part of the code when you are reviewing it, right? then you add a question there, and whoever is the author of that code answers their question, but they also add documentation, right, to make sure it's clear to anybody else. And so yeah, that sort of thing, gets added throughout, when you're working on your code before it's merged.
Yeah, speaking of documentation, I know this was addressed partially in the software architecture panel, but Alex, how does 254 ensure that they're getting good documentation and that's actually useful?
I think we generally have a bigger problem with like under documentation than over documentation. Yeah, usually documentation will be added before the review process. Another big time where we do a lot of documentation, I guess, is before we do public releases of code. Yeah, but in general, if you're confused about something that's going on in code, you can usually ask someone during the season, and they'll be able to tell you. It's obviously not ideal. It's another thing we need to work on, but it hasn't been like a super big issue yet in build season. So.
Okay. Yeah. How has for everyone, how has the review process kind of changed now that you're doing it remotely? And how much actual robot code can you write during this time with the absence of a robot to test on?
So, starting off when the pandemic first hit, it was end of build season. There wasn't really any code to write. So up until I think the summer, we had a little summer project that we did for like an off-season bot that was never going to get built, but it was just practice for all the veterans to just kind of get used to like writing code, because a lot of these veterans were new members back in January, and since the season was over, they're not considered veterans. So it's kind of their first like big on project where they each like had they managed it by themselves, they wrote the code by themselves. And then we kept the same pull request review process. We opened up a brand new repo as if it's like a brand new robot. It was kind of like a simulation, basically, of what an off-season robot would kind of be like. Sort of how things have changed because of COVID. I wouldn't say our pull request process got changed at all, but some of our lessons now, the first lesson that we taught about pull requests, we kind of did a group pull request on an old PR. Because that old PR had a lot of like changes that needs to get made to it. So we hopped on that together. We just screen shared on Zoom, and then people were like, oh yeah, hey, this is wrong. This line of code wouldn't work. This naming is just wrong. This styling is wrong. You need documentation here. Stuff like that. Just a lot of collaboration online. I think that really helped teach everyone, like how to make good pull request comments. How to make a good like pull request, like what to make sure you have before you start your pull request, stuff like that. So I think it's the only change that's happened due to the pandemic and online circumstances.
Alex, what about for you?
Yeah, I don't think I can really talk about the extent to which we've done like robot code and stuff. Especially this off season. Sorry about that. But I do think it's more helpful to be in person when doing when reviewing like pull requests and those kinds of things. But I think it's definitely doable online.
Mohammed, you spent some time talking about good pull request comments. What goes into that?
Like commenting on a PR or comments like from the author or from a reviewer? There's two sides to that. I can talk about both. Yeah. Okay, so the author, they create a pull request. Their title should be descriptive. It should just say like, oh yeah, write elevator code. I don't know. And then from that, you want to have like little bullet points that have they're as descriptive as possible for everything you do in the pull request. For example, set talent IDs to their proper ID number. tune the PID for it. I don't know, stuff like that. Just add maybe descriptive bullet points in your pull request, like that first block that comes with the pull request. And then for a reviewer, a good comment should be should just tell them like, oh yeah, hey. It should like sort of ask them, not point it out. It shouldn't be like a direct change. Like it shouldn't be change this to that. It should be, shouldn't this be that? It's just constructive criticism. It's not necessarily like bossy in any way. Another thing that comes with that is that the comments don't necessarily have to be changes. They can just be general questions like, hey, why is there an eye gain here and not in some other subsystem? Like, why does the shooter have an eye gain? Stuff like that. And then that helps veterans, new members, just everyone on the team like learn, because someone else could have had the same question, or just if you're the one with the question, you still learn from it. Like, yeah.
Alrighty. Does anyone have any other commentary on code practices, or if there are any other people watching, do you have any more questions about that? Okay. We're going to move into the last segment of the presentation, which is meeting over the web. Oops. Okay, so this is going to be focused a lot more around the grittier details of how you logistically implement the remote meetings. We're going to have a couple more poll questions associated with this, so stay tuned for those. Other than that, yeah. So we're going to start it off with how do you communicate? This is also a poll question, so yeah. So Porv, how does 1678 communicate online?
So almost like all of 1678's communication is done through Slack, right? We outside of meetings, right, we still have reminders and assignments and any timelines or guidelines communicated throughout Slack, right? Either in DMs if somebody has a more personal question, or on a Slack channel for the entire sub team. Something really important about communicating over Slack that I think was really good that we implemented throughout our competition season. Actually, Mohammed started doing was having an update for the changes made in that week, or on a specific day if there were a lot of important changes to be made, just to update the entire sub team on what's going on, right? And what are future things to work on, or what are tasks that we accomplished this week, right? And that just keeps everybody in the loop, everybody up to date with what's going on. And so being able to use Slack as that service to make sure that everybody is in the loop and understands what the sub team is working on right now, what its current objectives are, or even what its future objectives are going to be, like looking forward. That can be really useful for better understanding how we should go about things on the sub team, and making sure that if anybody has any concerns, we can address them immediately.
Yeah, so for like text communications, we used to use Mattermost in the past. Now we use Slack. So if you don't know, Mattermost is pretty similar to Slack, except it's self-hosted. So that like allows for a lot more freedoms with like messages and like image like total amount of images uploaded and stuff. But we switched to Slack we switched back to Slack this season because it's the image features are pretty nice, and like both Slack and Mattermost have pretty good features for like different channels, for talking to everyone in one channel, all those things. And then for meeting software, we use Microsoft Teams because our school uses Microsoft Teams, so they kind of want us to keep like all the communications on some school platform. Yeah, so we use Microsoft Teams exclusively for meetings, and Slack for other text communications.
Have you encountered any issues for anyone? Any issues with people doing too much important communication in DMs or places where it isn't visible, so you can't get a shared knowledge transfer between more people?
So, a lot of the time, if people have questions, right, on the sub team, then they'd prefer to ask it, like on their own, right, in a DM to, anybody who's leading the training or may have presented that lesson that day, right? So something we do to kind of counteract this, right, because we want to make sure that everybody can be more confident and involved with the entire sub team, so the entire sub team can gain knowledge. Something that we do is that we, suppose you present a lesson, then afterwards you provide, whatever material you presented in that meeting. And then you ask everybody to, thread questions in the channel, right? As, you could say as sort of an assignment, right? But it's really just, if you had any questions, please make sure to, thread them here. And that way, we can respond to them immediately on the channel and everybody can, learn from whatever questions those are. Because I think Mohammed mentioned this earlier, but overall, there's always going to be a question that multiple people have, right? And so it's just a matter of getting it asked so all those people can learn. And yeah, being able to do that on like a public channel, right, is then a lot more useful, right? Because you're not dependent on everybody DMing on their own. One person can do it and everybody can still learn.
How often do teams meet? Both as a full team meeting and also if you meet separately as a sub team.
So we have whole team meetings once a week. We also have some like whole team, like team bonding activities or like workshops or something. So sometimes that number will be more than once a week. As for sub teams, usually sub teams will meet. New members will have like meetings, maybe, or like new member specific meetings will occur maybe once a week for us, and then or just once a week, yeah. And then veteran specific meetings will happen also like once a week. So, yeah.
And then there is also a poll for that question, if we could get that up there. How often does 1678 meet?
1678 meets as a general team twice a week. They're pretty short meetings. They range from like 5 to 15, maybe 20 minutes sometimes. And after that meeting's over, we transition to sub-team meetings. We meet on Wednesdays and Thursdays, but we might not necessarily meet on both days. Sometimes we might choose to just meet one of the 2 days. It's a pretty good format, especially earlier in the season when we still had the new members. They're doing their own curriculum outside of software robot and software scouting. So we just split that up into like 1 days for veterans, 1 days for new members of the Wednesday and Thursday meetings. And that's a pretty good system, and it's still holding up pretty well because people can just schedule extra meetings if they need to as well, like over the weekend. So generally, yeah, we meet twice a week as a general team, and then at least once a week as a sub team.
Yeah. So I know that both of the teams have mentioned that you use virtual meetings. I think Alex said Microsoft Teams, and I know 1678 uses Zoom. So what do you do in these remote meetings?
So, most recently, like in our meetings, we've been doing a lot of like training for new members and veteran members. For new members, we've actually been going over Java in recent weeks, right? Making sure that they understand that because, so on 1678, we actually have everybody learn Python as a preliminary step in like a software general kind of group. And then, they can either move to software scouting or software robots. So on software robot, you finally make the comparisons between Python and Java, right, and introduce the new members to how Java works and how they can code in Java. And then, the next step of training is actually making sure that those programmers can get in more hands-on training with the work that we actually do on our sub-team, right? So understanding how subsystem code is written, understanding what PID is, right? Even understanding, what are ways you can write an autonomous, things like that get really important to be familiar with before competition season, right? Obviously, right now, one of the larger difficulties is, getting everybody to actually write substantial real code, right? But there's a lot of, projects or, code assignments that you can give to help encourage people to actually try out on their own, right? And write code and practice. I think, something cool that, we just recently introduced is that we're having our veteran members try rewriting previous code that was written in C++ into Java, right? To be able to practice their, skills, right? And be prepared for competition. So, that's a cool thing that we've been doing. And, you'll go over any material or any questions, etc. at meetings, right? To address concerns like that.
Yeah, a good amount of our workshops or our meetings are workshops as well. So we have like different, I guess, like learning tracks or curriculums, I guess, for new members and for veterans. So new members will generally be doing stuff from like Java, learning Java, learning like how to use version control, up to stuff like state machines. And then for more senior members, for advanced students, we'll have stuff like more advanced control theory, like EKF, Ramsat, peer pursuit, spline general, that kind of stuff. It's, that's generally what we do in meetings.
Okay. And then, so what does your, so two questions on this. What does your normal timeline look like? And what does your timeline look like for this year?
Like build season timeline?
Just kind of throughout the year. So from when you say from off season going into build season.
So during a normal year, actually no, during both years, I think we follow the same timeline. We have the new members first join. They learn Python with software scouting kids, and they split off generally around the same time. This year we split off a little bit earlier because we started the training of the summer, which was an advantage of being online. But then they continued training up until the first day of build season, and then from there we just tried subsystem code robot code up until champs. So it's about the same timeline. Just we got new members for the two sub teams a little bit earlier than usual.
In terms of like more specifics of the content we actually go over, a lot of the time, so we spend, like, at least this year we've spent about a month going over what Java is, right? We're hoping in the next month or so until like the beginning of competition season to go over more sub-team specific code, right? And then in competition season itself, right, you have a lot of subsystem code written like as soon as possible, right, within that first month and stuff. And then after that you go into working on the different more gritty aspects of your robot, right, throughout competition season. Yeah.
And then in the off season, I'm assuming you have slightly different timelines for new members and veteran members. Could you walk us through the differences?
Well, I think the biggest difference just comes through the training that is actually provided, right? Something that, we went over this about the peer-to-peer model, but a lot of veteran members are actually involved within our training, right? Because we want to, make sure that they have the chance to pass down the knowledge they have, right? And obviously get a learning experience out of it themselves. But while new programmers are, learning Java and then learning to write more sub-team specific code, veteran members on their own might be doing different projects, right, that we assign. So, for example, rewriting, previous code that was in C++ into Java is a project that our veteran members are now doing, right? Because, that's a bit more difficult, right? And we want to make sure that they're adequately prepared. So yeah, I think for veteran members, it's really just a series of projects and different learning opportunities that you can get on more specific parts of programming a robot, right? Like vision, for example, that we may go over.
Alex?
Yeah, so like I said before, we have kind of different curriculum for new members and I guess veterans. When we were actually able to work on the robot like last off season, the 2019 off season, generally what would happen is we would have like a new member workshop maybe like once a week, while like the veterans would go work on something to do with like the summer project or something. And then and then for this season, if we were to meet in person, the idea would be pretty similar, except this season we also have like advanced member workshops or veteran workshops. So generally, like new members would be going to work on other projects, while like the advanced members had, or the veterans had like a workshop.
Alrighty. As we're starting to run out of time here, does anyone have any closing thoughts on just in general how teams can improve the virtual experience?
I would just say in general, if anybody has, any questions about the workshop that they'd like to ask right now, please feel free to do so. But as kind of like my closing thought, I would just say that, these are definitely more difficult times, right? Everybody has a lot more reduced interaction between sub-team members and et cetera. But I think keeping up with communication, right, and just making sure you have something to do, right, even if it isn't, actually getting to work with a real off-season robot, right, even if it's still doing training or working on separate projects, being able to communicate and, work through things together in that way, collaborate on something, is really important, and, can make sure that you're still passing down knowledge, right, you're still creating a sustainable, a sustainable system for your sub-team. And it also, helps keep morale a bit higher. These are rough times, but we'll definitely all get through it. We just need to, keep it up and hope for the best.
Yeah. Unless anyone else has anything, I think that just about wraps it up. So thank you all for coming. Thank everyone for watching. Stay healthy, stay safe. Good luck in whatever happens later.
Yeah, thank you again for moderating.